Welcome to this TypeScript course. Through the next few hours, you'll learn all of the major features of TypeScript and then apply your knowledge by working through a practice project at the end of the course. The only prerequisite here is that you have a basic understanding of JavaScript, as you kind of need that to really see the value from TypeScript. Now, if you appreciate this teaching style, if it meshes well with you, and if you want to learn more and become a software engineer, then consider checking out my program with Course Careers. This is specifically designed to help you land a software developer job. We walk you through building your resume, your portfolio, what companies to apply to, and of course we teach you everything that you need to get to a junior software developer level. Not only do we teach you the fundamentals, but we allow you to choose a specialization in front-end, back-end, or DevOps, and that's been really crucial in helping our students land jobs, which we've already been successful with. If you're looking to become a software developer, if you're serious and you like this style of learning, then please check it out from the link down below at techwithtim.net/dev. With that said, let's get started with this TypeScript course. Hello everybody, and welcome to the first video in this course where I'll be teaching you TypeScript. Now, TypeScript is another programming language. However, it is a superset of JavaScript, and what that means is that everything that holds true about JavaScript is the same in TypeScript. It just adds some additional features that make JavaScript a little bit better to work with. Now, in order for us to understand why we would even want to learn TypeScript, I need to give you some background information and a bit of context about the different types of programming languages we have. So that's what this video will do. Then in the next videos, we'll actually get directly into TypeScript. So I want to start talking to you about a very important feature of a programming language, which is being dynamically typed or statically typed. All major programming languages that we work with are either dynamically typed or statically typed. Now, dynamically typed simply means that the type of variables can change at runtime, while statically typed is the opposite. It means the type of a variable cannot change once it's declared. Now, if you're unfamiliar with runtime, don't worry, I'm going to talk about what that means. But first, let's have a look at some JavaScript code. Now, we've probably seen this code before, you're familiar with what this does, and we declare a variable here and we make it equal to 10. Now, the data type of this variable is a number. And then later on in the program, we decide that we're going to change the type and we're going to change the value being held by my variable to be hello world. Now, some of you may not think anything of this, but we actually did something pretty important here. We didn't just change the value, we actually changed the type that was being stored by this variable. Now, that's interesting, and it allows us to use this variable in whatever way we want. Okay, so that's JavaScript, and that's really what dynamic typing means. Anytime throughout the program, we can go ahead and change the type of our variable, and it can store something completely different. Now let's have a look at some Go code. Now, you probably haven't seen this before, but Go is a language that is statically typed. Now, notice when I declare a variable here, what I actually do is I explicitly define the type that this variable is going to store. So I've said var by variable, and I've specified that this is going to store an integer. Now, what this does is it essentially locks this variable, and it says, okay, this variable can only store types which are integers, and then I assign it the value of 10. Now, later on in the program, if I decide to try to change my variable to hold a different type, you see that we actually get an error. When I hover over this, it says we cannot use hello world, which is an untyped string constant, as an integer value in the assignment. The reason we can't do that is because this is a statically typed language. In JavaScript, this would have worked fine because it's dynamically typed. But in Go, it doesn't work because it's statically typed, and once we define the type of a variable, it cannot change. Now, it is okay for me to store another number or another integer in here because it's the same type. But I can't change the type, and there's a very important reason for that, as we're going to talk about in this video. Okay. So that's the basics. We have dynamic typing and we have static typing. But at this point, you probably don't know why a language would be statically typed or why it would be dynamically typed. And this is where we need to talk about how programming languages are actually executed and ran. Now, we have something known as an interpreter. Now, what an interpreter does is it reads code and it translates that code line by line into something known as machine code or bytecode. Now, in order for us to actually execute the code that we write here, we first need to translate it into another language that can be understood by our machine or by something known as a virtual machine. Now, the point I'm trying to make here is that the code that we write is not immediately executable. We have some process we need to run it through before we can actually take the instructions we've given the computer and have them be executed. Now, there's many different ways to go about doing this, but when we work with JavaScript, typically what we're doing is interpreting this code. Now, all that means is that line by line, we're reading the code, we're then translating it kind of in live time into something known as machine code or bytecode, and then that code is being executed by the interpreter or by our machine, okay? That's what's happening with JavaScript. Now, the way I can illustrate this to you is the following. We have 4 lines. These are valid lines. Now, if I go here and I type node demo.js, let me just make sure I save this first, you'll notice that this prints out and everything works fine. Now, let's see what happens if we make a function. And I say something like function test. And then I go down here and I try to call the function 2 times. Now, we should know by now this is not valid code. And if I go here, I clear and I run, notice that what first happens is we actually print out the 2 valid print statements, or we execute the 4 valid lines of code. And then as soon as we reach this line here, we get an error, and then we see the error appearing. Now, this is known as a runtime error. And the reason we call this a runtime error is because while we were executing the code, while it was being interpreted, we came to a line that caused an error, and then it crashed our program. So during the execution or during the running of our code, this occurred. Now, what's important here is that we were able to actually execute the other lines of code before this exception occurred, before this error happened. And the reason why that's the case is that we've actually interpreted this language. That means that we go through again and we execute line by line. So we start at line 4, we read it, we declare a variable. We go to line 5, okay, everything happens fine. We go to line 8, 9, and then we hit 15 and an error occurs. Now, this is different than how code is executed in a statically typed language. In a statically typed language, we actually first run our code through something known as a compiler. Now, what that means is that we first read all of the code that exists inside of our program, we translate it into something that can be executed by our machine, and then we execute it. So rather than executing it line by line and translating it line by line, we first compile the entire thing, and then we execute. Now, what that means is that we're going to catch errors at a different point in time, at something known as compile time as opposed to runtime. Now, you'll see what I mean, but almost every error that we get when we work in JavaScript code happens while we're executing the code. That means that we actually need that error to occur for us to know that an error exists, and sometimes, depending on how the code's written, there could be an error that exists that we don't catch unless we hit a specific edge case or we do something specific in our code. I'm hoping this is making a little bit of sense, but I really want you to remember that we were able to actually do all of this stuff before this error occurred. Okay, now let's have a look at how we would do this with Go code. You don't need to replicate this, I just want to show it to you because it explains the difference between dynamic and statically typed languages. So in my Go code, the first thing that I do is I actually build my code, or I compile it. So I'm going to say go build and then demo.go. Now, when I do that, it actually creates an executable file for me that can be executed directly by my operating system. Now I have what's known as my compiled code, and I can simply run my code by doing something like this. Now, when I do, you notice that I get some output from my Go code. Let's go back to it so we can have a look at it here. So it first compiled the whole piece of code into something that we can understand, the computer can execute, and then we executed the entire thing. Now, watch what happens if I try to compile my code and an error exists inside of the code. Remember, it's a 2-step process. We first compile and then we run. So I'm going to go here and I'm going to try to build this code. Now notice that it actually doesn't compile anything for me. It gives me an error and it says you cannot use hello world, the untyped string constant, as an int value in the assignment. Now this is an error that happened at compile time, not runtime. Before I was even able to start running my code and executing it, I got this error. We didn't print out this statement right here. This didn't happen at all because we weren't even able to compile the code. Now, the reason this is an important distinction is because at this point, we now know that an error exists and we didn't need to actually run the code to find it. If we need to run the code to find errors, it can actually hide quite a few errors that exist, and it can make it a lot more difficult when you're working in larger programs to find errors and to see that they actually are occurring. So when we use a statically typed language, we're catching errors before we start executing the code. It doesn't even allow us to compile the code if we have these errors occurring. Now, what that means is that we're limiting the number of runtime errors we run into, and our code is typically a bit more robust and easier to understand. we have to have a clear definition or a clear type declared for any variable and actually many other things that we're using, and it makes it so that we can't do something that this type is not supposed to be able to do. Now I'm going to go back and just show you another example here, right? So in something like JavaScript, even though you've maybe never seen this before, actually let's have our test function back here. I can do some really weird stuff. I can say const result is equal to say test plus 2, and then I could say console.log result. Now this code is actually fine and it will execute, and I'll show it to you if I type clear and then node demo.js. Notice that we actually get this string here. It says function test and then 2. Now this is something that we probably don't want to be able to do, and that gives us a really weird output that's not very predictable, right? It's strange, it's weird. Anyone reading this code probably isn't going to have any idea what this actually gives us or why we would do that. And when we're reading it, we don't know what it's actually going to be. So in a dynamically typed language, you can do this really weird, strange behavior that is oftentimes hard to understand or is something that's not consistent or that most people aren't going to know is actually occurring. That is typically a bad thing. We don't want that because it makes our code a lot harder to maintain, and it allows us to do weird things that maybe aren't defined or that we don't want to be doing in our code. Whereas in a statically typed language, we would never even be able to do something like that. If we tried to do that, it would simply give us an error, and it would tell us that immediately while we're writing the code because it knew that we just can't perform that operation. For example, if I try to go to my variable and I say something like 10 plus, and then we add a string here, it immediately gives us an error right in the editor because it knows we cannot add a number to a string. That's just not a defined behavior because of the way that the types work. So I'm hoping this makes a little bit of sense, but the idea is when we're using a statically typed language, it's a lot stricter, it's a lot more robust. It's harder to make a mistake or an error because our compiler is going to catch all of these errors for us and just not allow us to do that. Whereas in a dynamically typed language, we can pretty much do anything we want, and even if this will result in an error, we're only going to know about that error if we end up executing that line of code while we're interpreting the language. So the main benefit of a dynamically typed language is that it's a lot more flexible. It's typically faster to write code in because we don't need to understand these types or define them. But when we get into large pieces of code, there's all kinds of weird errors that can be popping up. It's really difficult for us to understand what's supposed to be stored in different variables and how we interact with our different types. Whereas in something like a statically typed language, everything needs to be explicitly defined. We know exactly what the types of our variables are, and it allows us to write code in a more robust and predictable way because we understand what every variable should be doing, what it's storing, and what we can and cannot do. Now that leads me into TypeScript. What TypeScript does for us is it adds this static typing ability to the JavaScript language. Now you're going to see that in the next few videos, but the idea is we keep the flexibility of JavaScript while adding the enforcement and the great aspects of statically typed languages, and we kind of get the best of both worlds. So when you're working in a large project, it's typical you're going to start using TypeScript to really make sure that it's clear what everything's doing, and again, to get those benefits that I talked about before. There's some more things to understand, but I wanted to break down for you in this video what a static versus dynamically typed language is, how an interpreter works, and how a compiler works, and allow you to compare and contrast these two different styles of languages so that when we get into TypeScript in the next video, you understand why it's valuable and why we actually use it. You'll start to see more as we go through the series. But with that said, I'm going to wrap up the video here, and I look forward to seeing you in the next one. Hello everybody, and welcome to the second video in this TypeScript course. In this video, I want to break down what TypeScript is and its core advantages. Now, TypeScript is a separate programming language. It was actually designed and is currently maintained by Microsoft, and it's simply a superset on top of JavaScript. All that means is that all of the features you have in JavaScript exist inside of TypeScript, and it extends those features and adds some more functionality. Now, the main benefit of using TypeScript is that it adds a type system to JavaScript, which gives us static type checking and makes the development experience that much better. Really, the whole goal of TypeScript is to make writing JavaScript code easier and to allow us to maintain larger code bases in what would normally be a dynamically typed language. It kind of gives us the best of both worlds. It gives us static type checking while maintaining the flexibility of JavaScript, and pretty much allows us to enable or disable the static type checking whenever we see fit. Now, TypeScript is used by pretty much all large companies, any large code base is typically going to be written in TypeScript rather than in JavaScript. And if you start working as a developer and you are working in JavaScript, it's pretty much going to be assumed that you know TypeScript, and that's mostly what you're going to be writing code in. Now again, everything you already know in JavaScript applies to TypeScript. There are just some additional features that make this a lot more developer friendly and again, allow you to use it in a larger code base. So the first main advantage here is that using TypeScript allows us to actually check errors at compile time. So remember I was saying before that in normal JavaScript, a lot of the errors that you run into happen at runtime. And this makes them difficult to catch. It actually forces you to run, execute, and test the code to find these different errors. Now, when you get into a lot of code, this is far from ideal, and it means a lot of errors can get into the code base that you don't want. So instead, when we use TypeScript, we now add that compilation phase. We actually take our TypeScript code, we compile it into JavaScript code, and while that happens, we can find all the errors that can be caught with our type system. So we can see if we're adding a string to a number or if we're doing these weird operations that we don't want to happen in our production code. It allows us to catch our errors earlier, faster, and means that we don't have as many that run into our production code base and that actually are happening at runtime. Typically, you want all your errors to be caught at compile time before the code is executed rather than during runtime. Now, another major benefit of TypeScript is that when we use this type system, we end up documenting our code by default. What that means is we end up defining very clearly how a variable should act, what a function should do, what it should accept, what it should return, because it's just part of the way that we write code in TypeScript. Now that allows us as developers to have a much clearer understanding of what's going on in the code, and it also gives us some great features in our IDE. So in something like Visual Studio Code, when you start using TypeScript, you're going to get some great auto completions and you're going to be able to navigate the code quite a bit easier because you've declared and defined what the different types are. It's going to be a lot easier for you to understand how to utilize a function, and you're going to get some great error messages and auto completion, which really speed up development over the long run. So when you first start with TypeScript, you might ask yourself, why am I doing this? It seems really redundant. I'm writing out all of these types. But as the code base gets larger and larger, and you start to forget what you did months and years ago, having that documentation built in is really, really helpful, and it actually helps you speed up the development a significant amount. In general, TypeScript is simply a developer tool. It makes the developer experience that much better. It gives you a ton of advantages, features, and benefits. It adds that static type checking, and it's something you're going to want to use in any relatively large project. It can be a bit overkill if you're doing something that's really simple, but if you ever start working in a team or for a company, most likely you're going to be writing TypeScript code rather than normal JavaScript. Now that's pretty much all I had for you in this video. In the next videos, you're going to actually see how we set up TypeScript and what the types look like, and you're going to understand that it's pretty simple to use this, and it adds so many features and benefits that you'll probably just start using it from now on. At first, it seems a little overkill, it seems like you don't need it, but trust me, once you get into larger code bases, it's absolutely critical, and you're going to wish you had started writing with it. So with that said, I'm going to wrap up the video here. I hope you're looking forward to the next one, and I look forward to seeing you there. Hello everybody, and welcome to the next video in this TypeScript course, where I'm going to be showing you how we set up our environment for writing TypeScript code. Now, before I get into this, I want to mention that there are like unlimited ways to do this. And if you are working with TypeScript in a framework like React or Vue or Angular, it's going to be a significantly different setup. In this case, what I want to show you is just how we set up a very basic project where we can have some TypeScript files that can get converted into JavaScript code. Now, the idea is we can't directly execute TypeScript code. Well, there's certain tools we can use to do that, but in our case, if we want to use the node tool, the one that we've been using in previous videos, we need to first convert our TypeScript code into JavaScript. So the idea here is to understand how do we actually do that, and how do we get a simple project set up where we have TypeScript code. So I'm going to show you how we do that here. I'm then going to show you how we use something known as Vite to actually initialize a project from a template. Now the template is going to give us a bunch more options. It's going to have some code pre-configured for us. And I just want you to keep in mind that you don't need to memorize all of this. And once you get the setup done once, it's finished. It is a little bit of a pain. I'm going to include all of the commands that I write here associated with the lesson, so you can simply copy them in if you want. But just bear with me and try to understand the basic process rather than memorizing everything that I'm doing. Okay, so the first thing we need to do here is we need to make sure we have node.js installed. Now to check that, you can simply type node-v in your terminal or your command prompt. Now I'm going to recommend at this point that you open up Visual Studio Code and that you open up a folder. What I've done is I've gone to File, I've clicked on Open Folder, and I've opened one from my documents. So please open some kind of folder, and then make sure when you open your terminal that you're inside of that folder, as I am here. We're then going to type node-v. It doesn't matter what version it shows you, but you want to make sure you get some output. If you don't have that output, you need to install Node.js. To do that, you can simply Google Node.js. You can click on the first link here, and then you can install for your operating system. You can see I'm a bit out of date, but that's fine. Okay, so now that we have Node installed, we're going to start typing some Node commands, first of all to install TypeScript, and then to initialize a new project for it. So what we're going to do is we're going to type npm install -g and then TypeScript. Now what this is going to do is install TypeScript globally on your system, which will allow you to access something known as the TypeScript compiler. So go ahead and attempt to run this command by hitting enter. Now it's possible you're going to get an error that looks like this. If you do, you're going to prefix the command with sudo. Sudo stands for super user do. This gives you elevated privileges, which allows you to run this command. When you type that in, it's going to ask you for your password. If you're on Mac, this is the password you use to sign into your computer. When I hit enter here, it's going to install that for me. You see that it works fine. Now, if you're on Windows and you get that same error, what you need to do is open up your command prompt or your PowerShell, whatever terminal environment you're using, as an administrator. To do that, when you see the application, you right-click on it and you click Open as Administrator. Then you can type the command. It doesn't matter if you type it in the correct directory or not. You can just type it in any terminal instance. For example, I could open up terminal here and I can type the command. Same thing on Windows, okay? Just do that to install npm. Now the way you're going to know if this is working is if you type the tsc command. This stands for TypeScript compiler. And when you hit enter, it gives you some kind of output. It doesn't need to give you any files or do anything. It just needs to give you some output. So if you type tsc and it's working, you're good and we can continue forward. Okay, now what we're going to do is create a new project. Now to do that, we're going to type npm init-y. Now we're going to do this inside of the folder, and let me zoom in a bit so we can read this, where we're working in, right? So in this case, in VS Code, we're in the code folder, and we're typing npm init-y. When I do that, it's going to create something known as a package.json file. Now this file specifies some of the configuration for our project. What we're doing here is creating a new npm project, and this is a place where we can essentially specify different configurations, different scripts, different dependencies for the code that we write inside of this folder. You may not have seen this before, but typically when we're working with JavaScript or TypeScript code or any of the frameworks associated with them, we have a package.json file, which gives us some information about the current project. You don't have to worry about it too much. We're not going to dig into it a ton, but I want to explain what that file is. Now that we've done that, we're going to install TypeScript in this project as a dependency. Whenever we're working with TypeScript, we want to install it in the package.json dependencies so we know, hey, when you're in this directory, when you're working with this code, we need TypeScript installed. To do that, we're going to type npm install TypeScript and then --save-dev. Whenever you type npm install, it's going to look inside of the package.json file and it's going to add this as a dependency. It can add it as a dev dependency, which is what we're doing here, or a normal dependency. In our case, we only need TypeScript when we're developing, so we add it as a developer dependency. Go ahead and hit enter, and you'll see that it gives us package.json. It also creates a node modules folder, and it gives us a package lock.json. You don't need to worry about those files. Package lock is essentially specifying the locked version of the packages that we have installed and the dependencies. And node modules is storing all of those different dependencies. So if I look inside of TypeScript, we have a bunch of stuff for TypeScript that we need for it to be able to run. Again, don't worry about it a ton. It's just storing the dependencies for our project. Okay, so now we've got TypeScript installed. However, whenever we work with TypeScript, we want to provide a configuration file that tells TypeScript how to behave. There's a lot of different options that we can use with TypeScript, so we want to put them in a configuration file. To do that, we type npx tsc-init. Now this creates a new TypeScript configuration file in the current directory. So again, that was npx, not npm, tsc-init. When we do that, we get the tsconfig file here. Don't worry about this that's popping up, it's fine. and it specifies a bunch of different options that the TypeScript compiler will use when it compiles our TypeScript code into JavaScript code. Okay, so I'm going to clear that there, and now we have our package.json, we have our tsconfig, we have our node modules, and we're pretty much ready to go. Now what we can do is we can actually create some TypeScript code, and I can show you how we run it. So that was the basic setup. Create a new project, install TypeScript in the project, create the TypeScript configuration file, and now you just write some code and you can execute it. Now in a second, I'm going to show you an easier way to do this, but this is how we just get like the most basic setup possible. Okay, so next thing, we're going to create a new file. We're going to call this test.ts. TS stands for TypeScript. So that's the extension we're going to use whenever we're writing TypeScript code. Now inside of here, we can write any valid TypeScript or JavaScript code. You can write normal JavaScript, or you can add the TypeScript functionality. Now I'm just going to say const x, this is type number, is equal to 2. And I'm going to say console.log, and then we're going to log x. Okay, now this is valid TypeScript code. Notice that I've declared the type alongside the variable. You don't have to worry about this too much right now. However, I want to show you how we execute this code. So some of you may try doing what we've done before by typing node and then test.ts. Now when we do this, you're actually going to see we get an error, and the reason we get an error is that what the node command tries to do is execute JavaScript code. But this here is not JavaScript code. This is TypeScript code, so we're not able to use node to execute it. What we need to do instead is we need to compile the TypeScript code into JavaScript code and then execute the JavaScript code. The reason we do this is we write all our developments, we do all our coding inside of TypeScript, so we get those development features and those benefits. Then we use the TypeScript compiler to convert it into JavaScript, and then we execute the JavaScript. So the way that you use the TypeScript compiler is you simply type tsc inside of the directory where your TypeScript code exists. So in this case, it's inside of code. So I type tsc, and you see that it creates a new file here called test.js. Now it looks a little bit different, but you'll notice that it's removed the TypeScript component, and it's just added the equivalent in JavaScript. That's all it's done. So now that we have test.js, we can execute that by typing node and then test.js. Okay, so again, to summarize that process, you write the TypeScript code, you then compile the TypeScript code with the tsc command. If you have multiple files, etc., it will do that for you, and then you execute the JavaScript file that you want. In this case, it's test.js. Okay, so that's one way. However, we can speed this up a little bit by creating some scripts. So we have this package.json file. And inside of here, we can actually specify some scripts, which are really just commands that we can run to allow us to perform these operations a little bit faster, or whenever there's repetition, we just put it inside of a script. So inside of package.json, we're going to start editing this, and where it says scripts, we're going to create a new script. So I'm going to delete this test one, and I'm going to name this script. We'll actually just go with run. Actually, no, we'll call it dev. Now we're going to put a colon, and we're going to write the command that we want to execute when we run this script. Now what this is going to be is tsc. We're then going to put 2 ampersands, and we're going to have node and then test.js. Now what this is going to do is create a script for us that will first compile the code, and then after that's done, it will then execute the code for us. So now what I can do, since I have this in my package.json, is as long as I'm inside of this project, I can type npm run. When I type run, it's now going to start looking inside of the scripts, and then I can specify the name of the script I want to run, which in this case is called dev. When I do that, notice that it runs the tsc command, it compiles into test.js, and then it executes the test.js file for me. So now we've just ran one command rather than 2, and it just kind of summarized what it is that we need to do to actually execute this code. Okay, so there we go. We now have successfully written TypeScript code. If we want to write any more TypeScript code, we can just do it directly inside of this file. So that is method 1. Again, all of those commands will be linked in the kind of lesson description. Now what I want to show you is how we actually do this from a template. So let me delete all of this, and we're kind of going to restart here using something known as Vite. So what I'm going to do now is paste in a command. And this command is simply going to set up everything that we had before. We're just going to do it automatically for us with some additional configuration. So I'm going to paste this command in here, and by the way, there's a bunch of different commands like this. This is just the one that we want for a vanilla or normal TypeScript project. Now, what you should understand is that TypeScript is used with a variety of different front-end frameworks. So it's used with things like React, Vue, Angular, and the setup for all of those is going to be quite a bit different. Most times projects will already be set up for you, or there'll be a single command you can run that will set them up, but it's still important to understand what the commands are, especially if you want to work on a slimmer project that doesn't have all of these different frameworks. So in our case, the command we're going to use is npm init vite at latest. Vite is a front-end build tool essentially that will allow us to very quickly execute code and gives us some templates, as you're going to see here. We then have the name of our project, which is being my Vite TS project. I'm going to change this to just be project instead. We then have dash dash and then dash dash template space vanilla TS. What this is saying is create a new project using Vite with the vanilla TypeScript template. So if I hit enter here, it's going to give us the commands to actually execute this code. So we're going to cd into project, so that changes our directory, and you'll see now that we have this project directory here. Now what this is set up for us is a vanilla kind of HTML TypeScript project. So we have an index.html file where we can render some code and we can do some stuff inside of here like we normally would with HTML. We have our package.json, which has some different scripts set up for us, as well as our dev dependencies of TypeScript and Vite. We then have inside of source the contents of our TypeScript. So we have counter.ts. Inside of counter.ts, we have some TypeScript code, which eventually will be converted to JavaScript for us. We have a main.ts file. The main.ts file imports this code from counter.ts. You don't have to worry about this too much right now. And it actually injects some code into our web page. We then have some more stuff like this that you don't need to worry about. And what else? We have a public folder with vite.svg. That's just a logo that it's going to be displayed on the screen. So what we're going to do now is we're going to type npm install. What npm install does is it looks inside of package.json and installs the different dependencies. So in this case, the dependencies are TypeScript and Vite. When we run this, we'll see that a node modules folder will be generated just like we had before. And now we're able to actually execute our code. Now to execute our code, we have some scripts. We have a build script. Notice this does exactly what was happening before. We're doing a TypeScript compile. So we're compiling the TypeScript code into JavaScript. And then what Vite build does is create a build or a bundle of all of this code for us. You don't have to worry about that too much. We then have dev. What dev will do is simply run the web server, and preview generates a preview. Now, what we'll do for now is we'll type npm run and then dev. When we do that, we're going to see that we can go to this URL here. So we can copy this. Let's paste that inside of our browser, and let me bring this up, and you'll see that we get the project, and we can hit count here and we'll see that it goes up. Okay, now we can click on these. There's some animations and stuff. You don't have to worry about that too much. So that's what the npm run dev command does. You can hit Control-C to exit out of that. And then we also have the option to do npm run build. Now when we run build, you're going to see that it does tsc and Vite build. And what it does is it creates something known as a bundle for us. So if we go here, we have dist, which is distribution. And inside of here, we have index.html. And then inside of assets, we have an index.js bundle, which is essentially a bundle of all of our TypeScript code inside of one JavaScript file. Now, I don't want to explain this too much because it gets a little bit complex, but what this has done for us is it's used the TypeScript compiler and it's used this Vite build tool to take all of our TypeScript code and convert it into JavaScript code, which is now associated with this index.html file. So now what we have here is this dist folder, which is the distribution, which essentially contains all of our code. It has our bundles, it has our CSS, it has this index.html. Again, I don't want to get into this too much in depth because it is a little bit complicated, but what we've done here is converted our TypeScript code into JavaScript so it can now be executed. Now, this is in the context of working with an HTML file. For the rest of this video, or for the rest of this series, we're just going to be working with normal JavaScript so you can see how TypeScript works, but that's the idea. So I think with that said, I'm going to wrap up the video here. Now I know this was a bit complicated and there's a lot of setup that I showed you, but I wanted you to understand how we set up a standard TypeScript project and then how we use this Vite template. It's getting a bit complicated with Vite. It's not something you need to fully understand at this point in time, but the idea is we're constantly converting that TypeScript code into JavaScript and then executing the JavaScript code. Now that we understand the setup, in the next video, I'm going to talk to you a bit about this tsconfig file. Then we're going to start getting into some more details about TypeScript and actually writing code in that language. Hello everybody and welcome to video 4 in this TypeScript course. In this video we're going to be going through the tsconfig options, just so you're familiar with a few of them, and then we're going to move into the next section where we actually start getting into the types. I know there's been a bit of setup here and we've gone through quite a few options and a lot of configuration, but I just really want to make sure you understand it so you're not lost as we get into the next videos. So actually, just to ensure that you really have these steps down, I'm going to repeat what I did in the last video just quite a bit faster this time. I've opened up a new folder, we have Node.js installed, and I want to create a new TypeScript project. To do that, I type npm init-y. What is this doing? It's creating the package.json file for me. Next, we need to install TypeScript. So we type npm install TypeScript, and do you remember this? It's --save dev, because we're saving this as a dev dependency. And then we create the TypeScript configuration file, which is npx tsc-init. Okay, so that creates our TypeScript configuration file. Now we create a TypeScript file. I'm going to do app.ts. You can call this anything you want. And there you go. We now have the project created. Pretty straightforward once you know the commands. Okay, now that we have this, let's go into the tsconfig and let's start going through a few of the options here. Now notice there are a lot of things that we could potentially do. Obviously, most of these are not going to be relevant to us, but there are a few that we're probably going to want to look at and be aware of. So first of all, what is this file actually doing? Well, it's really just specifying a lot of options for our compiler and some project settings that are important as we're writing TypeScript code. Now, most times we don't need to change any of the settings here, but sometimes we will want to modify a few of them. So I'll just go through some of the important ones, but keep in mind they all have comments explaining what they do. And once we get into using specific frameworks or we have some setup we need to do, we'll go in here and change anything and we'll mention it directly to you. So first of all, we have things like language and environment. Most of these you don't really need to look at, but we have the target. We can do ES 2016. There's a few options we can put there as well, like ES6, ES5, and this kind of specifies what type of JavaScript code we want to get as an output. So set the JavaScript language version and how compatible that's going to be with different browsers. Next, we have modules. Now for here we have a few options. Common.js is the one that we're using right now, which allows us to import things using the require statement and something known as module.exports. We also have the ability to specify this as ES6, and that now changes it so that we'll end up using a different style of importing and export that's a bit newer. We then have the root directory. Now if we comment this out, this is where we tell the compiler to start looking for our TypeScript code. So // is going to look inside of the directory where the tsconfig file is, whereas if I had like a source directory here, I would change this something like /src. So then I only look inside of here for my TypeScript files, and I don't get any errors where it starts scanning through code that's not supposed to be looked at by the compiler. Okay, so that's one that you actually probably will use quite a bit. We then have a bunch of other ones in here as well. We don't need to look at too many specifically. And we can scroll down and we can have a look at some more. So for example, we have one, allow.js. Now let's say you don't have this, so we comment this out, and then you have some JavaScript code that's in your source where the compiler is looking. It's actually going to throw an error and tell us, hey, like you can't have any JavaScript code, it all needs to be TypeScript. That just means you have a .js extension file, not a .ts file. Then we also have one like enable error reporting in the type check JavaScript files. So that's checking the JS. Sometimes we don't want to do that. And then we have a ton of other stuff here. So for omitting, this is what happens when we actually output the compiled JavaScript code. Now we have things like the out file. So what file do we want to bundle all of the outputs into? We have an out directory. What directory do we want to put all of the code into? We have a bunch of other things in here as well. I don't need to go through all of them. And then as we keep going, we get into things like the type checking. So this is one that's pretty important. We have an option which is strict equals true. Now when we do that, it enables all strict type checking options, which essentially means it's not going to allow us to actually compile the code if we have any TypeScript errors that are being strictly checked. Now we can make this false if we don't want to check all of the strict options. Sometimes that's the case. And then we have specific options in here that we can enable or disable. So we can allow unused labels, we can allow unused variables, we can allow blah, blah, blah. You know, there's a bunch of stuff in here that we can specify and see if the compiler is going to check that or not. So for example, no unused locals, we can make that true. Always strict, true. No implicit this, true. Like a bunch of different options inside of here. Now, there is some other options that we can specify in here. I'm not going to go into them right now, but for example, we can include specific files, we can exclude specific files, we can reference different areas, we can bring in custom types. There's a lot of stuff that goes into this file, but I just wanted to briefly run through it. Now, just to show you what will happen if we actually write some invalid code, let's see what happens if we do something that contains like an invalid type or something like that, okay? So I'm going to make a function. We'll just call this test, and we'll take in x, which is a number, and we're simply going to return a number, and this is just going to be return x plus 1. Now notice, first of all, if I don't actually return something here, I get an error, and it says a function whose declared type is neither undefined, void, nor any must return a value. So I actually have to return a value. And then if we go here and we call something with like test hello, you'll see that it's giving us an error, and it says an argument of type string is not assignable to a parameter of type number. So let's see what happens when I try to compile this code. I'm just going to type tsc, and notice it actually gives me an error here. It says argument of type string is not assignable to parameter of type number, found one error in app.ts:5. So it gives us this compile time error when we try to compile this code. Now, you can go back here and change this to app2, and now it actually works, and it doesn't give us that error. Whereas I could actually go and I could disable this error checking inside of the tsconfig file if I wanted to do that, so it no longer gave us that kind of output. So I think that's pretty much it to show you right now. I just wanted to quickly kind of run through a few of the options inside of this file and show you what's possible and what you can do. For right now, we don't really need to change anything. We'll just leave it as it is, and we'll do the rest of this series in this setup that we have right now. So no changes to tsconfig. We just have a normal app.typescript file, and in this file, we'll write some TypeScript. I'll explain to you the different types, how you create interfaces, types, how you type functions, how you type variables. You get the idea. We'll go through all of it, and I look forward to seeing you in the next video. Hello everybody, and welcome to the next section in this TypeScript course. In this section, we'll be talking about the basic TypeScript types, starting here with the primitive types. Now, primitive types are the most basic types we have. There are things like numbers, strings, booleans, null, undefined, essentially the simplest type that exists inside of, well, any programming language, but in this case, JavaScript and TypeScript. Now, I want to start by showing you how we type different variables, and then we'll look at these types in isolation so you understand what they are and how we use them. It's going to seem really basic right now, but as we move on to the more advanced types, you'll see why it's important, first of all, to understand these. Okay, so we can create a variable, and let's say we have a variable x, and we make this equal to a value like 2. Now, first of all, this is completely valid, and we don't need to explicitly define the type here. Now, explicitly defining the type simply means you put a colon, and then you specify, in this case, the primitive type that this variable is going to hold. So I've said let x number equal 2. This is explicit as I'm actually writing it out. However, if we don't do that, we still have set the type here, and x is storing the type number. This is simply implicit, and what that means is because it has a number here, TypeScript can determine that this is of type number, and it simply sets the type of x to be equal to a number. What I mean by that is if I go here and I try to change this to something like a string, we now get an error message, and it says type string is not assignable to type number. So just to be clear, we have both implicit and explicit type setting. I don't need to actually write out that this is type number. Whatever I assign to this variable is by default the type that it's going to get. Okay, we can change this, we can do it with a string, and you'll see we get the same thing here, right? If we try to make this a number, we now get an error because now x is of type string. Now, when would you use an explicit type? Well, you use an explicit type when you're not actually giving this a value. So I can say something like let x equal a number, and now I can set x equal to 2. So I'm declaring, hey, I have a variable x. I don't want to assign something to it yet, but I want its type to be a number, and then later on I can go ahead and use that as a number. Okay, so that's the first primitive type, which is a number. Now let's actually go back to the example we had before. Numbers can be many different things. They can be like a 2, so this is a positive number. We can have a negative number. We can have a 0. We can actually have infinity. This is a number as well, represents the concept of infinity. We can have negative infinity, and we can have floating point values as well. So something like 67.2, sorry. These are all considered numbers in JavaScript. Now you may also see that some people write number with a capital N. Now this is what's known as a wrapper around the primitive type. Now this is something that you shouldn't use unless you have an explicit reason to. I just wanted to show it to you because there is this concept of like number with a capital and then lowercase number. You want to use the lowercase number, okay? And that's the same for all our other primitive data types. So there you go, we have numbers. Now as well as numbers, we have strings. So a string is simply a collection of characters that is enclosed in single or double quotation marks. Something like x equals hello, this is valid. Something like x equals hello with double quotation marks, this is also valid. Even a number inside of here, well, this is still a valid string, okay? Now we also have a few other types of strings we can write. For example, we can have a template string. Now this is when you use backticks, and inside of the backticks, you can embed variables using a $sign and then the curly braces. So I could do something like let y equal 10, and then I can put y here, and this is still considered a string type. I believe this is called a template literal, where you can actually embed variables or expressions inside of the string. So that's all part of the string primitive type here, okay? Now as well as that, we have Boolean. So for the Boolean type, you can simply type out Boolean. You could say x is equal to true or to false. And let's just test this. If you try to do x equals 0, you get an error. X equals 1, you get an error. It needs to be the Boolean type of true or of false. Okay, so those are our three basic primitives. We have a few others as well that we want to look at. All right, so now we need to talk about two types which are commonly misused, and this is the null and the undefined type. Now it's going to be difficult for me to integrate these into the type system right now because we haven't shown you some more advanced types. Just bear with me throughout the rest of the course and you'll understand how to use them within TypeScript more correctly. Anyways, let's say we have some variable result, okay? And we make this equal to null. Well, I want to explain what the difference is between null and undefined. So you use null when you want to explicitly define something as empty or non-existent. So in this case, we're saying, hey, result is null, and that means that we don't expect this to be equal to anything else, and we are very clearly setting it equal to null. So we're saying, hey, it's non-existent, we don't have a result, we don't expect it's going to change. That's when we use null. Whereas undefined is more used as a placeholder when we haven't yet defined a value, but later on in the program, we might change this. So we might start with the result equal to undefined, and then we may change the result to be defined later on, or at least we expect that's going to happen. Undefined is typically used as a placeholder value when you expect that you are going to have some result in the future, whereas null you're using to explicitly declare something as empty or non-existent, okay? So you want to make sure you understand that difference. Now notice when I set this equal to a variable, so I say let result equal null, that it implicitly gets the type of any. The reason it gets the type of any is because now I can use result and I can set it equal to something else. So I can say result is equal to 2 or to 3. That's fine because when I make it equal to null, and this is something that can change, so it's using the let keyword, we have no idea what value is going to be stored inside of result, and it could be anything. Now you may be saying, well, why don't we just set a type and we do something like number? We can't actually do this because null is not assignable to the type number. So if I simply put some variable here, right, and I say let result equal to null, by default its type is going to be any. When you have an any type, all that's doing is explicitly omitting the type checking. So we're saying, hey, for this variable here, I don't want you to check the type. It could be anything because we've set it equal to null to start. So just don't bother checking its type, which means I can do something like result equals 2, result equals a string, and notice we don't get any type checking errors. Now the same thing happens if we make this undefined, the type becomes any, again, because we don't know what it's going to be. Okay, now if we want to, again, we can set this equal to an explicit type, but then we're not able to assign it to undefined unless we do something known as a union. We're gonna look at this later on, but I'll quickly show you. I can say let result equal number or undefined, and now we start it as undefined, and then later on, I can say something like result equals 2, and this becomes valid. I don't want to get into these types too much because they're a bit more complicated, but you get the idea. We have something known as a union operator, and that means we can have either of the two types here that are separated with the union. Okay, so that is null and undefined. We also have two other types that I'll quickly go over and we'll look at more later. we have the void type. Now the void type is simply to be used when you are returning nothing from a function. So sometimes you have a function, this function does something, but it doesn't return a value. In that case, the return type of the function is void, meaning it doesn't return anything. We also have a never type. Now this is not one that we're going to use too often, but this type is to be used when we want to explicitly define that a function never returns and that a code path should never be reached. We'll see, again, using this type later on. It's a bit more complicated, but I wanted to quickly show you that it does exist. Okay, quick recap. We have the number type for numbers. We have the string type for strings. We have Boolean. We have the undefined value and the null value, which can also be types, but typically we're going to use them in conjunction with another type. We have the void, which is when a function doesn't return anything, and we have the never type. Those are our primitive types. Now we're going to move on to the next video and talk about arrays and tuples. Hello everybody, and welcome to the next video in this TypeScript course. In this video, we're going to be going over arrays and tuples and how you do the typing for those types of data structures. Let's get right into it. Okay, so first of all, what is an array? Well, an array is an ordered collection of elements. Looks something like this in JavaScript. We can make some variable var arr is equal to an array, and then we can put some values in here like so. Now notice when I do this, if we hover over here in TypeScript, we get that we have an array, and the type of the array is a string or number, and then it specifies it's an array. Now this is the idea, okay? When we're creating arrays, and we'll talk about tuples in a second, we want to define what types can be stored inside of the array. In JavaScript arrays, technically you can store any types that you want. However, it's going to be a lot better when you're storing the same type inside of the array. It makes it a lot easier to work with this array and to get the correct type checking, as you'll see later on. For example, if I do something now like array 0 plus 1, notice that we actually get an error here, and it says the plus operator cannot be applied to the types string or number and number. The reason for that is when we do this, TypeScript doesn't know if the first value in the array is going to be a string or a number, so when I try to add 1 to it, we get an error. Even though we can see that it is indeed going to work, this will not allow us to compile because we have different types that are being stored inside of this array. Not sure if that's clear, but you want to make sure that you just try to stay with one type in the array if possible. And if you are going to be using multiple types, you have to do some more advanced type conversion and checking, which I'll show you later on. Okay, so we have our array, and right now if I look at this, we can see that this is the number array, right? That's the implicit type that this gets assigned. Now, as well as implicitly being assigned that, we can explicitly write that out. And the way we write that out is we specify the type of the elements in the array, and then we put a set of square brackets indicating that this is an array. Okay, now if I were to change this to a string, that would mean that all the values inside of my array need to become string values. Okay, so that's it for defining an array. You put the type that's going to be inside of the array, followed by a set of square brackets. Now if you want to get a little bit more complicated, you can do a nested array. Now notice what happens here. I have string and then I have two array symbols. What this actually indicates is that I have a nested array where the elements inside of my arrays are strings, right? So we can look at it and see if we hover over array here, we have a double string array. If I remove this, you see we get the same implicit type here because we have arrays inside of arrays and the elements inside of those are strings. Now, if you get a bit more complicated here, watch what happens if I add something like a 1. Now notice we have a string or number with an array, okay, so kind of like a nested array. And watch what happens if I change one of these to something like a 1. We get an even more complex type now, where we have string or number of an array inside of an array. So hopefully you get the idea here. You don't want to be mixing and matching a ton of different types inside of the arrays, because if you do that, you get all these union types because there's multiple possible values that could be in any single position. So whereas before I might have been able to do something like array 0 dot length, now you can see that's not going to work because it says the property length does not exist on the type number. Whereas if we remove the number here, now this works totally fine because we know that we're getting some type of array and we can access the .length property on it. Now this is where TypeScript really shines. It gives us great autocomplete based on the type of the operations we're performing and of the data that we're working with. So we want to make sure we always have the best types possible. So that's pretty much it for the arrays. Notice though, if I have an empty array here, the implicit type is just going to be an any type array. We don't want that. We want to have an explicit type. So whenever you define an empty array like this, I recommend that you explicitly write out what the type is that's going to be inside of this array so that you get the best auto completion and type checking throughout the rest of the program. Okay, so that's it for arrays. Now let's talk about tuples. So let's say that we actually want to store something like a coordinate pair, okay? So maybe like an x, y value. Well, we could just put that in an array, right? And I could do something like const chord, and let's say this is a number inside of an array, and then we have something like 1, 2, where x is 1 and y is 2. This is fine. However, if we know that we're only going to have, say, 2 elements or 3 elements or a certain number of elements, we can actually create something known as a tuple. Now, a tuple is a fixed length array that has defined values for each position in the array. So let me show you what I mean. I can do something like number, and now what I've specified is that I have a tuple here where we have 2 elements, and the first element is a number, and the second element is a number. What this allows me to do now is have type checks and type hints for each element in the array. So if I do something like console.log chord at index 0, we know that when I access index 0 here, I have the type of number. Now, to show you this a bit better, if I were to change this to something like a string, and this now becomes 2, and I access chord 1, we know that this is going to be of type string. Now, this differs from if we were to do this with an array. So watch, if I remove this here now. So now when I hover over the 1, notice it's not giving me any type hint at all. And when I hover over chord, it's saying it could be a string or a number. Keep in mind, what we've done is the exact same thing. We have the same value as before, but when we explicitly write out that this is a tuple, now we know what the value of each position in the array actually is, which gives us better type hinting and the ability to use this significantly better. I'm hoping that makes a bit of sense, but again, here, chord 1 knows this is a string because we've defined this as a tuple. Now, we can go a step further, right, and we can make this as many values as we want. So I can say number, number, number. And now we can do 1, 2, 3, and now we have a tuple with 3 elements inside of it, and we can use all 3 of these elements with the correct type hints, and it will know what type each of these different elements actually are. So let's just go one step further and create a slightly more complicated type here, just so you get the hang of it. Let's say we have some chords, so we have multiple coordinates, okay? What we're gonna do is specify that we're gonna have a tuple. This tuple will be a number, number, and then we're going to have an array of these tuples. Now what I'll do is inside of the array here, I'll specify multiple tuples, so like 1, 2, -1, 3. And what I've done now is I've created a type where we're storing tuples inside of an array. So the type itself is number, number, and then the array. Now just to illustrate how good the type hints get when we do this, if I do something like chords, 0 at index 1, and I hover over this, it knows that we actually have number as the property. The reason it knows that is because we've specified that the first index in our tuple is of type number. If we wanted to make this even more complicated, we could have number as an array type here, and now we can specify arrays in here, right? And I can put some different numbers. And when I hover over this now, you see that we get an array of numbers as the type. All right, so that is arrays and tuples. Hopefully it's making a little bit of sense. The idea here is that when we have these types explicitly defined, we're able to more easily use the data inside of here. And you can see that because in my IDE, I get these type hints, that's what these are called here, telling me what the types are. And based on what those types are, I now get some great auto completion for the different operations that I can perform. And it's telling me what's allowed on this type and what's not allowed on this type based on the type of the data that we're working with. That's where a statically typed language really has an advantage, and that's why we use something like TypeScript, so we get those type hints, we get that auto completion, and we know what we can and cannot do without relying on running the code and testing it out manually. So with that said, I'm going to wrap up the video here. I hope you enjoyed, and I look forward to seeing you in the next one. Hello everybody, and welcome to the next video in this TypeScript course. In this video, I'm going to be talking to you about literals and enums. Now, a literal is simply some specific value. You're going to see what I mean in a second, but when I write something out like 23, or hello, or true, all of these are literals. In this case, this is a Boolean literal. This is a string literal, and this is a number literal. A literal is really an instance of a primitive type. That's the way that you can think of it. So let's have a look here at where we would use literals and how they fit in with TypeScript types. So let's say we have some variable, which is direction. Now, this direction is going to be something like north, south, east, west. We could simply say that this is going to be the type string, and then we can say direction is equal to something like north or south, or maybe it gets assigned based on some logic that we have in our code. The thing here is that if we know this variable is only supposed to be one of 4 different values, rather than allowing it to be any string, we can actually write a literal or multiple literals that can be assigned to this value as its type. What I mean by that is the following. Rather than writing string, we're going to do north, or, remember this union type, south, or east, or west. Okay, and let's just make this a little bit bigger so that we have some space. Now notice when I hover over direction, the type of direction is one of these 4 literals. What that now does is it makes it so that I can only assign one of those values to the variable direction. If I try to assign the string hello, notice that it gives me an error and it says hello is not assignable, to the type north, south, east, west. So I've specified the 4 valid things that can actually be assigned to this direction type or to this direction variable. So that's quite useful when you have functions or you have logic where you know you're going to be handling only a few different sets of string values, and it lets you have a more strict type check and also gives you some good autocomplete. For example, if I go here and I say if direction like this equals, and I start typing, notice that it will automatically fill in the 4 different literals that it could be equal to because it knows this type is only going to be one of these 4 different literal values. Okay, so that's one example of a literal. Another example is the following. We could have something like let response code. And again, we could just make this equal to a number, and then maybe we say the response code is equal to 404. However, if we want to be a little bit more exact, we could say, okay, well, the response code is only going to be equal to 200, 404, or 201. Now, these are just valid HTTP response codes. So now if I go response code equals 2, you'll see if I do 2, this is invalid. If I do 200, that is okay. So these are literals, and you can use them as a type. You also can just have like a single literal. So I can say let response code equal true, and now the only thing I can assign here is true. If I try to do false or anything else, I'll get an error because the type itself is simply true. All right, so those are literals, and similar to that, we have something known as enums. Now, enum stands for enumeration, and this typically is some variable name which is associated with some integer. Now, we can have numeric enums, which I'm going to show you first. We can also have string enums, which can be useful. The basic idea behind enums is that rather than hard-coding strings or hard-coding numbers, we can make our code a little bit more readable and easier to understand by encoding different values with kind of variable names, as you'll see here. That's a bit of a bad explanation, but I'm going to show you how we write an enum. So to create an enum, you simply write the keyword enum. You give the enum a name, and then you put a set of braces, and you define the values inside of here. So I could do something like small, medium, and large. Now, the way you access an enum value is you write the name of the enum and then one of the values. So we could say size.small. And what we're doing here is we're creating a logical area where we define different values, and these values are actually mapped to integers. You're going to see the benefit of them in a second. But small, by default, is actually going to be equal to 0. Medium is going to be equal to 1. And large is going to be equal to 2. Now, this makes a bit of sense because small should be the smallest value, 0. Medium is the middle, it should be 1. Large should be 2. Now, the reason we use this rather than having a string like small, medium, large, right, if we wanted to create a string literal, is that when we just have strings here, they're not put in context. So small, medium, large could really mean anything. In this case, we're associating each of these names with the size. So we know it's actually part of the size enum. Also, in this case, I can use 0, 1, and 2 to represent any one of these three sizes and then compare them with the actual enum value. You'll see what I mean in a second, but let me make a variable. So let's say I have a variable size. I can say the type of this is size. So first of all, this is immediately a lot more clear and easier to understand than if I were to write out, small or medium or large. I'm actually specifying, hey, it's going to be of the enum size, right? Then I can make this equal to something like size.small, or I can make this equal to 0, right? They're the same. So 0 is equal to size.small, so it gives me the benefit of the fact I can map integers to a text representation that I can use in my code. Another benefit is that it's very clear for me when I want to start writing these out or comparing values. So I could say if the size is equal to size.small, then go ahead and do something inside of here. This is completely valid. I can either have 0 or I could write, size.small here. So we just have an integer mapping with a string representation. And now if I want to change it, so maybe I want to change small to be something else. So now what I could do here is I could hit Control and then F. I could say, okay, I want to replace small with smallest, and then I can just find and replace. And now we've replaced all of these and everything stays the same in our code. Just kind of a simple example there, but when we use the enum, we typically get better autocomplete. We have the ability to refactor, and it's a lot more clear because we have all of our values in the context of what they're supposed to mean. Now this is a numeric enum, and it's worth noting that although these values will automatically be mapped for us, we can manually map them ourselves. So I could say large is equal to 10, medium is equal to 5, and smallest is equal to 0 or to 1. It doesn't matter, you can set it whatever you want it to be. Now, same thing, we can remove this, and if I start smallest at 1, you'll notice the other ones will just go up by 1 starting at this value. If I make it 100, then this will be 101, 102, totally fine. So that is a numeric enum, and we also have the ability to create string enums. So for a string enum, I could do something like enum direction, and now we could say that we have up associated with up, so let's go up is equal to up. We have down is equal to down, and actually let's make this in all capitals. Okay, we have left equal to left, and right equal to right. Okay, so now same advantage here. When we use a string enum, we are logically grouping different things together. Now we know up is always associated with the string up, down associated with the string down. We can perform their comparisons. And the advantage here now is if I decide that I want to change one of the string representations, I could change this to like a lowercase left, for example. It won't mess anything up in my code because I'm using this variable that's associated with the text. A lot of different instances where you want to use a string enum, but typically it's when you want to organize a group of string constants, values that are not going to change, with some logical variables that you can use throughout the code. Again, the advantage here, let's actually make another enum. Let's say enum description, and let's go small text is equal to, and I'm going to do this with a capital because that's the convention, is equal to this is some subtext to read. Now what I could do is something like this. Okay, I'm going to say console.log description.small text. And what happens now is if I change the small text to anything later on, right, it'll change for every instance of the description.small text. And it's very clear for me when I'm reading this, I know, hey, oh, I'm printing out some small text, which is a part of a description. Whereas if I just have a variable, right, and the variable is called small text, so we say let small text equal this, it's a little bit less clear when I end up using this in the program later on because it's not logically a part of some kind of group, and I don't know if the small text is for a description, if it's for a header, if it's for a different part of the page. So that's kind of the advantage of using an enum, and specifically in this case a string enum. So I know that this is a little bit vague and it probably doesn't make 100% sense right now, but the idea is an enum allows you to map values, or in this case kind of variable names, with constants. They can be numeric, they can be strings. It allows you to logically organize them together, and you can use them as a type. So as you saw, we can type them with variables. I could say something like var value direction, and now the only valid things for this value are one of these 4 strings, and rather than writing out the strings, I can use the direction.up, down, left, or right enum. Hello everybody, and welcome to the next video in this TypeScript course. In this video, I'll be going over the any type, the unknown type, and then type assertions, and a little bit about type casting. Now let's begin by talking about the any type. Let's say we have some variable x, and we explicitly type it as any. Really what this does is it tells the TypeScript compiler to ignore type checking for this variable. So what that means is I can do something weird like call x as a function, or I can try to look for the length of x, or I can do all of these things that we know are not going to be supported on x because it is the type any. So when we use any, we simply ignore all of our type checking. Now, see how that differs if I explicitly type this with number. When I type it with number, notice we get our error message here because now it knows that something like length isn't going to be valid on x. So you use the any type when you want to manually ignore type checking for a variable. Now, when would you actually use this? Well, you use the any type typically when you're in a very complex situation and you're not able to actually write out or predict what the type of the variable is going to be. You can also use any when it is reasonable that you could be receiving many different types. However, I'm going to show you an alternative which typically is better to use. The idea is when we write code in TypeScript, we want to avoid doing this unless we really have to, but there are some scenarios, especially more complex ones, where you're not able to explicitly define what the type is, or it becomes more complicated to write the type out than it would be to simply specify it as any. You'll see what I mean as we go through the rest of this course, but I need to show you the next type here, which is unknown. Now, the unknown type is typically what you're going to want to use as opposed to using any. Unknown is when you don't know what the type's going to be, and what this does is not ignore the type checking, it actually forces you to check what the type is before you start performing an operation. So I'll show you a few examples so you get the idea. If we try to do something like x plus 1, notice that we actually now get an error. It says x is of type unknown. Now we know that it's a number, but since we've typed it as unknown, TypeScript wants us to explicitly define what the type is before we actually go ahead and use this. Now we do that with a type assertion, and there's a few ways to go about doing this. So what I can do is I can write an if statement, and I can say if the type of x is equal to something like a number, then I can go ahead in here and I can perform some type of operation. So I can do something like my constant result is equal to x plus 1. Now notice this works fine, and the reason it works fine now is because we've asserted that the type of x is a number. So now we know because of the assertion that's here that x must be a number, and the TypeScript compiler is smart enough to realize that and actually tell us that, hey, this is a number. Now if I put an else statement here, and I try to do the same thing, so let's copy this in here and paste. Notice that now we get an error because at this point in time, we've not asserted what the type of x is. Now to go a step further, if we were to add an else if here, and we say type of x is equal to something like a string, well now that's going to work because we can actually add a string to a number. We also could do something like the result is x.length. Right? And this now is perfectly valid because we know the length property is on a string. And when we look here, we can see that x is of type string. So the idea is with the unknown type, we need to first assert what the type is before we can actually start performing an operation. Now, this is a lot safer than using the any type because it forces us to actually handle the different cases and the different types we could be accepting. So typically you want to use this unknown type when you're not sure what the type's going to be, or it could be changing or just not well defined. And then you're going to check through the different cases of what types you could actually have, and then you can perform the operations based on the type that you have, and you'll get the correct type checking. Now, this is one way to handle unknown. Another way to handle unknown is to perform a typecast. Now, typically you want to be careful when you do the typecast as well because it's not as safe as what I'm showing you here, but it is something worth looking at. So let's say I have something like my const result, and again, what I want to do here is maybe access a property like .length, or I want to add values together. Well, I'll say const result is equal to x plus 1, and again, we're going to get that same error because it says it's of type unknown. However, if I know what the type of x actually is at this point in time, I have some insider knowledge that the compiler doesn't know, I can cast x to that type and tell the compiler x is this. Now to do that, I can say x as number like this inside of a set of parentheses. And what I've done is I've just manually told the TypeScript compiler, treat x as if it's the type number and then add 1 to it. So this is known as a cast. I'm taking this type and I'm essentially converting it or telling the compiler what it should be treated as. Now I can do this with anything that I want, right? So I can make this x as string and then we can add some string to it. I even could make this an array. I could say x as maybe an int double array, or sorry, not int, this needs to be number, and now I could access different indices here, and this is perfectly valid. Now this code will crash during runtime because x is not actually this type, and that's where the danger comes in here when you use a cast, right? So if I use this type of casting mechanism and x isn't actually the type that I've casted it to, then I'm gonna run into a runtime error, which is gonna defeat a lot of the purpose of me actually using TypeScript. So instead, I would want to first check if the type of x is equal to, and then I would write out the type that I want to see if it's equal to, and then I would perform the operation, right? So that's really what you should be doing with unknown, but there is instances where you can perform this type cast. Okay, so that's unknown and any, and I just want to look at a quick example here of when you would use any versus unknown. I know we've already talked about it a little bit, but I want to show you kind of the difference you get here. So I've just copied in a function here, and we haven't looked at typing functions yet, but I think this will be a clear enough example. See here that we have some function, and we've typed the input as any, and we've said that we're just returning void. So that means there's nothing that's being returned from this function. Now what we're doing is we're simply calling this function, and we can call it with any type of input because the type is any. Okay, so this is an example where you can use any, it's perfectly fine, and you see that input is just any, and we'll just print out whatever the input ends up being. Now let's look at a difference where we use something like unknown. So I'm going to copy in a different code snippet here. Let's paste this in, make it a little bit smaller. And notice now the difference that we have in our code. So we've typed input as unknown, and what we're now doing is we're checking all of the different possible types we could have for our input. Right, so we could have a string, we could have a number, we could have a blob. You don't have to know what that is. It's just a special data type in JavaScript. And you can see that when I start passing in values here, right, this is accepted as a string, this is accepted as an int, this is accepted as a blob, and I can perform specific operations based on the type that I have. Now, if I decide to put something in here that's not supported, so an array, for example, where we have 1, 2, 3, what will end up happening is we'll go into this else statement where we'll say, hey, this is an unsupported type of input, and we won't actually end up printing that out or doing anything with that. Now you might be saying, well, isn't the other example much simpler? Yes, it is, but the problem is, since you can pass anything into the function and we're not asserting what its type is, you can pass something in there that could potentially break the code inside of the function. In this situation, when we assert what the type is first, we know that whatever operation we're performing will indeed be valid, and then if we have any case that's not handled, we can actually handle that logically, we can throw an error message, we can tell the user, and we have much safer, more maintainable code. What you have to remember is that TypeScript is a developer tool that's meant to make our life easier and essentially reduce the number of errors that we're going to run into. So you don't want to start using any all the time and avoiding the TypeScript compiler when it actually is there to help you, even though sometimes it will seem like it's being annoying and getting the types can be kind of difficult. So again, you want to always try to use unknown rather than using the any type, because unknown will force you to perform this type checking here, which is what we want to do in almost every situation. A lot of times if you read code, you'll see people lazily type things as any. They're doing that because getting past the TypeScript compiler can be difficult when you're using the actually correct types that you're supposed to be using. So they'll just put any to avoid having to do some extra work. We don't want to be the developers to do that. We want to be doing things correctly. So try to use unknown when possible versus any. Anyways, that's all that I had for this video. I hope that it was helpful to you, and I look forward to seeing you in the next one. Hello everybody, and welcome to the next video in this TypeScript course. In this video, I'll be going over the question mark and the exclamation point operator. Now these operators allow us to check and deal with undefined values, which can be quite common within TypeScript. So let's look at an example here where we have some array. Now on this array, we have some objects, and these objects have a name field. Pretty straightforward. I just want to show you what happens if I try to do something like this. So I'm going to say const el, standing for element, is equal to array dot pop. Now, if you're familiar with .pop, you know that what this does is removes and returns the last element from the array. So in this case, it would give us name and chain. However, when we hover over pop here, we can see that its type is telling us it's either going to return an object that has a name that is a string, or it's going to return undefined. So the type of this function, right, is either name, string, or undefined. Now in that case, what that means is if I try to access something like the name property on the object that's being returned and removed, we actually get an error. If we hover over here, it says the object is possibly undefined. Now you're going to see this quite a bit, where in our case, we know that this is actually going to give us a valid object. However, TypeScript won't allow us to write this code because the way that this pop function or pop method was implemented is that it could potentially return undefined. So what we need to do is figure out a way to handle this so that we can deal with this potentially undefined value and we don't get an error in our code. How do we do that? Well, there's two ways to do this. The first way is to put a question mark. Now, when I put a question mark here, what this does is the following. It looks at the result from this statement and it first checks if it's undefined or not. If it is undefined, we simply stop and then we just assign undefined to this variable. If it's not undefined, it will continue going through the chain and looking at the next property that we specify. So we have array.pop, we put a question mark, it says, okay, only keep going if this value is not undefined. So we keep going and we get name, and then there you go, we end up returning the name. So this is kind of a safety feature that we can use in TypeScript, where if something may potentially be undefined, we put the question mark before we specify the property, and that way we're not going to get any errors where we try to look up the .name property on an undefined value. Okay, so that's how the question mark works. Now there's a specific name for it in JavaScript and TypeScript. I don't remember exactly what it is. It's something fairly complicated. The idea is though that we're going to check if the thing to the left is undefined. If it's not, we'll continue. If it is, we just return undefined from this whole statement. So now when we look at this variable, we can see this is going to be string or undefined. Now this will actually continue to work and we can use this multiple times within the same statement. Let me set up another example and I'll show you that. All right, so I've just set up another example here, and now notice that we have a nested array that has an object named Tim inside of it. Okay, so now how do we change this statement so that it works and we can still access this name property? And we want to do this safely. Well, we have array.pop. Now notice that this object is going to potentially be undefined. So what we can do is we can add a question mark here. So now what will happen is we'll check if this is undefined. If it's not, then we'll continue moving throughout the sequence or throughout the chain. So now we come here. Now when we pop from the interior array, again, whatever we get could be undefined. So we need to put another question mark. And now that we have two question marks, everything is working fine. And we're only going to reach this statement here if both the first array.pop and the second array.pop return to us a valid object. That way, we only try to access .name if we actually have something to access, right? So that is how you use the question mark operator. Now, what's similar but kind of the opposite to the question mark operator is the exclamation point operator, which is known as the bang. So when we look at EL here, you can see this is going to be string or undefined. Now, what if we didn't want it to be string or undefined? We wanted it to just be string. Well, if that was the case, we could actually switch these operators to be an exclamation point. Now, when I switch this to an exclamation point, notice that this is simply string. The way that the exclamation point works is it essentially forces the type of whatever we're looking at here to be not undefined. So if I hover over this, I don't know if it's going to tell me the exact type here. It's not, so you can't really see. But the idea is that rather than checking if it is undefined or not, it simply says, assume this is not undefined. So we move to the next one. It says, assume that this is not undefined, and then we access .name. Now, this is quite a bit different than the question mark because in the question mark, we're only going to go if it's not undefined. Here, it doesn't matter whether it's undefined or not. We are going to move on to the next statement. Now, what that means is that this whole statement is always going to show in TypeScript that it's going to return a string because it's ignoring the fact that it could potentially be undefined. Now, this is slightly problematic, though, because if we don't actually have a defined value, so if any undefineds do appear in here, we're actually going to crash our code and we're going to get an error. And the reason we'll get the error, is because we'll be trying to access a property on an undefined value, which isn't something you can do in JavaScript. So to quickly recap, the question mark is checking and then moving forward, whereas the exclamation point is forcing us to move forward. Now, the reason you use the exclamation point is when you want to force the type to be something specific, and you know with certainty that you are actually going to have the value that you're looking for, and it's not going to be undefined. However, it's typically very bad practice to use the exclamation point, and you can almost always get away with simply using the question mark instead. So you should prefer using the question mark operator. However, there are instances where you do need to use the exclamation point, and again, that's to force the value to not be undefined so that you end up having the correct strict type as you go through the rest of the program. Now, something that's common is that you'll see an exclamation point just come after a statement like this. When we do that, same thing. We're going to assume that this type will not be undefined. So now when I look at EL, you can see that this is going to be an array of an object with name of type string. So those are the two operators that I wanted to show you. This is known as the bang. Again, it's pretty bad practice, so don't use it unless you absolutely have to. Instead, you should really use the question mark operator and that optional chaining that I showed you. Anyways, I'll wrap up the video here. I hope you found this helpful, and I look forward to seeing you in another one. Hello everybody, and welcome to the next video in this TypeScript course. In this video, I'll be talking about functions. Now, this is definitely where it gets more useful because functions are a little bit more vague. They're harder to understand the type implicitly, and this is where you do actually want to be manually typing everything because you're kind of documenting the function by doing that. Now, you'll see what I mean when we start writing this out, but let's get into an example. So let's say we have a very simple function. We can say function add, and we can take in some numbers x, y, and then we can return something like x plus y. Now notice right away, the TypeScript is going to get mad at me when I have a variable in here that I've not explicitly defined the type of. It says the parameter x implicitly has an any type, and that's because we haven't decided what the type should be. Now, first of all, you'll notice the TypeScript won't even compile here. It won't allow me to compile this code because I haven't defined the variable types. So I have to actually explicitly define them. I can't just leave them as any. If I did want them to be any, or I wanted them to be unknown or whatever, I would have to actually type them explicitly for the error message to go away. Now, in this case, we want these parameters to be numbers. So we'll simply say that the function add has x as a parameter, which is of type number, and has y as a parameter, which is of type number. Now, this is a very simple function, so it's easy for us to imply what the type should be, but you can imagine that in more complex functions, this is very useful. This now allows me, when I'm writing my code, to actually view the documentation for this function. Notice when I start typing add, right? I get autocomplete and it tells me what I need to actually pass inside of the function because I specified that, and I pretty much have some built-in documentation. It's saying that we're taking x, which is a number, and y, which is a number, and this function is returning to me a number. So immediately we get this, which is a huge benefit, makes it much more clear how we use the function, and I don't need to actually see the function definition or go read through it to understand how I would use it. I know I've said that like 10 times. I'm just trying to drill the point home that when you're in a large code base, you want to very quickly be able to write code, and the ability to reference what the function should actually be accepting as parameters and what it's going to be returning is really, really useful. Okay, so here I can do something like const result is equal to add, and I can take in my values 1, 2. This is great, and you'll notice that I don't need to explicitly define what the function is returning. It will simply look at what the return statement is, it will gather what the type is, and then it will tell me that, hey, since we have a return statement which is returning a number, this function must be returning a number. Now, I can't get my mouse to hover over that, but you get the idea. Now, what I can do, if I'd like, is I can manually specify, the return value. So I can say, hey, this function should return a number. And now I just need to make sure that I do return a number and actually that all code paths return a number. Now let's have a look at that. So let's say I do something like if x is equal to 0, then return invalid. Notice that we actually get an error here. And it says that we can't do this because the type string is not assignable to the type number. Since I've explicitly defined the return value here, I'm not able to actually return a string. I would need to instead return a number. Now, if I were to remove this explicit return here, you'll see that this is now valid. And the reason this is valid is if we look at the function, it will actually tell me that it's going to be returning number or invalid. because that's what both the return statements here return. So it just gathered all these types and it's unioned them together. Now that's not ideal. We don't want that, but in some cases functions will return different types, and in that case TypeScript can actually kind of see that, it can infer it, and it can tell you. Now here, if we wanted to do that, it would be better for us to probably write something like number or string and specify, hey, we're returning a number or a string from this function. Okay, so let's get out of that though, and let's remove this. Perfect, so there you go, that's how you type a function. Now let's look at some other aspects of typing the function, because for example, we may have a optional parameter, we may have a default parameter, there's some more things we may be doing. Okay, so let's say we have another function here, and we can do something like make name. Now for this name, we're gonna take in a first name, which is a string, a last name, which is a string, and a middle name, which is also a string. And then we're going to have our function, and let's make this a little bit smaller so that we can read it. Now the thing is, not everyone has a middle name. So it's reasonable that we may actually want middle name to be an optional parameter, and that means that we don't need to pass it to call the function. So you'll see here if I go and I do something like const name equals make name, and I'll go with my name here. So we'll go, this is Tim Rasika. And then I would need to specify another value. And why is this giving me an error? So let's just change this to full name so that doesn't give us an error anymore. Anyways, idea is it's going to force me to actually pass a middle name here unless I specify that it's optional. So you'll see it's telling me, hey, an argument for middle name was not provided. You need to go ahead and provide that. So a useful error message, but in our case, we don't want that. So what I can do is I can simply add a question mark here before the colon for my parameter. And now what I've done is I've declared that this can be, look at it here, it'll show you the type if I hover over it, a string or undefined. That just means that this is an optional parameter. And by adding the question mark, you're specifying that and kind of explicitly doing this. Great. So now I can pass that, or I don't need to pass that. And if I go inside of the function, I can decide to use this or not to use it, right? So I can say if middle name, then return the first name plus a space plus the last name plus a space plus the middle name, although I realize we need to do this in another order. So let's go middle name plus a space plus the last name. Okay, so that's valid. And then otherwise we can return the first name plus a space plus the last name. Okay, so that's how you do it with an optional parameter. Now, as well as optional parameters, we can have default parameters. Now, a default parameter is something that has a default value. If I wanted to do that, I could change this around. So maybe instead of having this be optional, I say middle name string is equal to middle, like that. And now the same thing works. I don't need to pass this because anything that is a default parameter by default is optional. All right, so that's it for actually typing the functions. However, I want to talk to you about the function type itself because we can use this in some instances. So I'm going to write an example that will seem a little bit complicated, but it's going to illustrate where we can go with TypeScript and why it's important to really understand these types. So let's say I have a function that is call func. Now what we're going to take in is some function, and we're going to take in param1 and param2. Now what this is going to do is it's going to take in a function that it will call, and it's going to take in a parameter 1, which is a string, and parameter 2, which is a string as well. Now for the function, I want this to actually be a function. So the way I want to call this function is I want to say call func, and then I want to pass this function itself, which is actually an object in JavaScript that we can pass. And then I want to pass Tim, and then I want to pass Rasika. So how do I make it so that I actually specify that I'm accepting a function here inside of my function parameter? I know it seems like we're in the matrix here, function, 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 but this is a thing. So how do we do that? Well, the way we do that is we write the function type. So we can actually do this in a few ways, but the first way that I'll show you is we can simply write out an arrow function that has the types that this function will be accepting. So in this case, our function is going to have 3 parameters, right? First name, last name, and middle name. So I can simply do something like first name, and I don't need to write out the full name. I can call this anything I want. So I can do something like F string, L string, and then M question mark colon string. And then the return type for this would be a string, And let me just format this so that it's a little bit easier for us to read. So what I've just done here is I've specified, hey, this function is going to take in a function as a parameter. Now, the function that it's taking in, well, we need to define the type of that function because that's how we'll use it inside of the function. So I say, okay, well, the type of the function is simply all of the parameters that the function can accept, as well as the return type of the function. So when I highlight over this, right, this that you're seeing is the type of this specific function. So each function has its own type based on the parameters, the type of those parameters, and the return value of the function. So I need to specify this out. I say, okay, we have f, which is a string, we have l, which is a string, and we have m, which is a, a string as well, but this is a optional parameter. And then we say with the arrow function syntax that this is gonna return a string. So now I can go and I can use this function. So I can say func param1 and param2 without getting any TypeScript compiler errors, because I know what the type of this is actually going to be, and it adheres with this type, which is what I pass in to the call func function. Okay, a little bit complex, I understand. Let's do one more example here where we look at how we would call multiple different types of functions. So I'm gonna do a bit of a complex example here to illustrate how we get kind of deeper into the types. So let's say we have some function and we're gonna say mul. We're going to take x, y, these will be numbers, and we return a number, and here we'll just return x multiplied by y. Okay, now let's just do the same thing, and let's just call this div instead, and we'll just return the division. Okay, so pretty straightforward, but I want to show you how we write a function that would actually take in multiple functions, because it can be interesting to see how we type this. So we're going to say function apply func. And what we're going to do is we're going to take in some functions. We're going to do that type in a second. And we're also going to take in some values. And then we're going to return an array with all of the results from the different functions. Now, I know this is confusing right now, but my idea is to do the following. I want to call this function like this. Mul, and then div, and then I want to pass tuples with two values like this. Okay, so this is how I want to call the function. The idea is that mul is going to have the tuple 1, 2 applied as the different arguments, and then what's going to happen is this is going to return to me an array that has the result of calling these two functions with these arguments. Okay, so go ahead and pause the video and see if you can figure out how you would type this function to accept the input that I've specified here. Okay, go ahead and pause it. I'm going to show you the answer now. So we need to start with our functions. For our functions, we need to define the function type. Now the function type is a number, b number. Remember the parameter name doesn't matter, it's just the types, right? And then this returns a number. The issue is though, we don't just have one function, we have multiple functions. So how do I actually get this to work? Well, what I'm gonna do is surround this type in parentheses, and I'm gonna put a set of square brackets. Now notice when I do that, I no longer get an error message here because this type, an array of functions that accept two numbers and return a number, is now valid, right? And if I hover over this, you can see this is the type. It's an array of functions that take two parameters or take two arguments, which are numbers, and returns a number. That's the type. Now for values, what do we do? Well, for values, this is gonna be an array. So we're gonna say we have an array, and then the type inside of the array is gonna be a tuple, like this, number, number. Okay, so we have number, number, and then this is an array, so we have a tuple of numbers, and then for the return type, let's see if we can specify what that's gonna be. Well, it's simply gonna be a number array. Okay, and what is the issue here? Oh, it's saying that we don't return that, so we just need to return that value. Okay, so now what we're gonna do is just write a little bit of code that will actually generate the appropriate return values. I know you can't see all of the code right now, don't worry about it for now. We're gonna say const results is equal to an array, but since I'm writing an empty array here, I now need to type this array because we don't know what's gonna be inside of the array unless I type it. So I'm gonna say const results is a number array like that. Another way that I could do this is I could say as number like that, and now you'll see that it gets number. Okay, so either way you want, but we'll do it with the cast. Now what I'm gonna do is I'm gonna say for, and this is gonna be const, and actually it's not gonna be const, it's gonna say let I less than the funcs.length, and then I plus plus. Now what is the issue here? Well, we need to assign I equal to 0. Then we're gonna say that results dot push and we're going to push, let me just make this a bit more clear, the const result, which is equal to the funcs at I called with, and then this is going to be the values at I, and we're going to need to break this apart even more. Bear with me, I'm writing this on the fly. We're going to say const args equals this, and then we're going to say args 0 and args 1. And then we're going to push the result and return the results. Don't worry, I'm going to break down this code. I know I went very fast. Okay, idea is the following here. We have a function, apply func. We take in an array of functions and we take in an array of tuple values. We then return an array of numbers. We say, okay, we have our results. Results is an array of numbers. We then say we are going to loop through all of the different functions that we have just using a normal for loop. We say we have some arguments. These arguments are going to be equal to the values at index I because those are the arguments for the corresponding function. We then have the function, which is at functions I, and we're going to call with the two arguments that we have. Notice when I hover over any of these things here, it tells me exactly what the values are, and that's because we have the correct TypeScript types. So now when I look at apply function, we know that it's going to return to me an array of numbers. Okay, I think that's clear. You can pause the video and look at it more if you want, but I just wanted to show you how we wrote a more complex TypeScript type here with a function. So you can see why it would be useful to write these types out for functions. Now when I start using this down here, I know exactly what it is that I need to type in here. Even if it's complex, it's better to have that documented so we wouldn't have to read the code to understand what the type actually is. Can you imagine, right, if I didn't provide the type and I told you, hey, figure out how to call this function, it's going to be a lot more difficult than if I just put the type here. Anyways, with that said, I'm going to wrap up the video here. I hope you found this helpful, and I look forward to seeing you in the next one. Hello, everybody, and welcome to another TypeScript tutorial. In this video, we're going to go over some more advanced function types, starting with REST parameters and then getting into overloaded functions. Okay, let's begin with a REST parameter, which is something you may not have seen before. So I can actually define a function that can take any number of arguments. Now the way I do that is something like this, where I say function sum, I put 3 dots, and then I can put something like numbers. And then for the type of this, I need to specify an array type. So what I've done here is created a REST parameter, and this essentially means that I can take as many arguments as I want. So that means I can call the function by calling maybe sum of 1, 2, 3. I can call it with no arguments, or I can call it with 2 arguments or as many arguments as I decide. When you add the 3 dots here, that indicates that you're collecting as many values as is passed, and those will be stored inside of an array. In this case, we're calling it numbers. So the type that we use is simply the array type with whatever the type of the value is that we're accepting. That's it for the REST parameter. Not too much more I need to show you here. I just wanted to indicate that you can do this with TypeScript, and this is the type that you would have. Actually, I'll quickly mention that maybe you want to start with some parameter before you have the REST parameter. You can do that. So maybe we have something like str string, and then we have the REST parameter. In this case, we would always have to pass 1 argument, which is some string, and then we can pass our different numbers, which will be collected in this array. Okay, so now we get into something a bit more interesting, which is overloaded functions. Now, an overloaded function is simply a function that has different call signatures and can accept different types. Now, we've seen before that if we want a function to accept different types, so let's do something like get item length, for example, what we could do is use the union type. Now, the union type looks something like this, where I have, say, value, and the value could be equal to a string or maybe an array of strings. Now this is fine, but the issue with using a union type like this is now when I want to start operating on this variable, I need to perform all kinds of typecasts. And also if I have multiple parameters, it's possible that we want those parameters always to be the same type, or we want the return type to be different. So what I mean by that is maybe I have, say, value 2. And now in this case, the value 2 could be a string or a array string, right? Or sorry, array of strings. The problem here is the way that I have this written is now there's 4 different ways that I could call this function, right? I can call it with a string and with an array of strings. I can call it with 2 strings. I can call it with 2 arrays of strings. I can call it with an array of string and string. And that may not actually be what I want. What I may want instead is a function that accepts just 2 strings or just 2 arrays of strings. I'm hoping that makes a little bit of sense, but when you use the union type, it's a little bit less strict and it gives some unnecessary flexibility when you don't want that. However, sometimes we want to write a function that can accept different types of values, and in that case, we use an overload function. Now, this is going to look weird, but just bear with me when I write this out. So I'm going to copy this, and I'm going to paste this a few times. Now, right now, we're getting an error because these functions have the same name, but you'll see that when I start changing the type, everything will be fine. So we're going to have one version of this function, which will take in a string and which will return a number. We're going to have another version of this function, which will take in some names, and this will be an array of strings, and it will also return a number. We're then going to have another function down here, and this is going to say name or names. This is going to be the unknown type, and it's also going to return a number. And for the two functions up here, rather than defining a body for them, I'm just going to put a semicolon. Now, what this has done here is actually defined an overloaded function. What this is saying is we're going to have this function getItemLength. We're going to write the body of this function in 1 second, don't worry. And this function can be called in one of the two following ways. It can be called with a name, and then it returns a number, or it can be called with names, and this type is an array of strings. So in this situation, we're defining all the valid ways to call this function, and then what we do is we write a general function down here, which can handle any of these different types of input. So let's look at how we write the body of the function. We say if the type of name or names is equal to a string, then we'll do something in here. Otherwise, we'll say else if, and we can actually check if this is an array by doing array.isArray, and then name or names, like that. Then we can do something here. Otherwise, we can return 0. Now, if it's a string, what we'll do is we'll return the name or names dot length. And if it's an array, then we'll return the name or names dot length. Now, I know this is technically the same thing. However, in this case, we're able to handle what's happening if we have a string or if we have an array. So what we've done is we've written an overloaded function. This is not the best example in the world because it's not super complicated, but the idea is we have multiple ways that we can call this function. If we call it with just a string, that's valid, and we'll handle that inside of the body here. If we call it with multiple names, so inside of an array, that's valid as well, and no matter what, it's going to return a number. Now, for the parameter of the general function down here, we don't know what the type is going to be. It could be anything that we have in our overloaded function signatures. So we write it as unknown, and then we can cast the type in here and handle the correct type. We then just have a return 0 here, so if none of this is the case, if you called something that's not valid, then we just return 0. Now let's see what happens when I try to call this. So I can say getItemLength, and you'll notice that what it's actually showing me here is that we have the function and it has one overload. Now the overload indicates to me, if we can click into this, getItem, let's see if it expands for me, that there's multiple ways to call this function because it's overloaded. So I can say getItemLength, and I can pass simply a name that's valid, or I can pass an array of names. And again, that's perfectly valid. Now we also could even return something different from this function. So for example, we could say return number, and then we could say maybe return string. Now what I'll do is I'll change this so that we're going to return unknown. And then here we can return, when it's a string, a number, which is the length. And when it's an array, we can return something like hello world. And that's completely fine. So when we define the unknown type as the return, when we go here and we look at getItemLength, it's going to tell us that because we're calling this with an array of strings, it's returning to us a string. However, if I call this with just a normal string, it can detect the correct overload and tell me that it's actually going to be returning a number. So I'm hoping this is clear, but this is how you write an overloaded function where there's multiple different ways to call it. You define all of the valid ways to call it with this syntax right here. You then write one general function which handles all of those different ways and returns the correct values. That's all I had for you in this video. This probably isn't something you're going to use too often, but I wanted to show it to you because it's kind of cool and it shows you the power of TypeScript and what we can do when we start getting a little bit more complex. Hello everybody and welcome to another video in this TypeScript course. In this video, we'll be going over interfaces. Now, interfaces are our way of creating types for objects. They allow us to create some more complex types, and I'm going to show you some examples of them here. So let's begin by defining an interface. I know it's going to seem very abstract. Just bear with me, and I promise it will make sense as we go through the rest of the video. So let's create an interface, and we're going to make a simple one called person. Now, inside of the interface, we need to define all of the different properties that any object that is of this type will need to declare. So what I mean by that is we might have a property like name, and we specify that this is the type string. And then we may have a property age, and this will be the type number. Now notice I'm not assigning any values here. All I'm doing is specifying the different properties that I want an object that is of type person to have. So now what I can do is I can say const person colon person, because I'm specifying, well, the type of this object is going to be a person. And then inside of here, what I can do is specify my property. So I can say name Tim and age something like 23. Now notice when I do that the TypeScript compiler error goes away, and that's because I've written all of the properties out that this interface has. Now the idea behind interfaces is that it allows us to view different objects as a specific type. So in this case, we're able to look at this object here as the person type, which means we know that when we're interacting with it, we're going to have a property name, which is a string, and we're going to have a property age, which is a number. So if I go down here and I say person dot, you can see that my properties are appearing in the autocomplete list because we know this is of type person, and it must implement these properties. So the basic rule with interfaces is that whenever something implements the interface, it must have all of the different properties from the interface inside of that type or inside of this object. So if I were to add an additional property, maybe say something like height, and this is a number, now I need to add height to my person object to satisfy the interface. Now let's say we want to have an optional value. Well, in that case, we can put a question mark here. And what I've now done is said height is optional. We can have it or we don't need to have it. And in that case, if I go here and I say person dot height, you'll see that it's optional and it's either going to be a number or it's going to be undefined. Okay, so that's the very basics on interfaces. They're super useful because they allow us to actually interact with more complex objects and understand what properties they have. Now within an interface, we can also add methods or we can add functions. Now these are still considered a property, but if we're talking about object-oriented programming, we consider them something like a method. So for example, we could add a function and we could call this hello. Now for the type, I'll make this a function type and I'll specify that this is simply something that returns void. So what I've done is I've written the type, we take in no parameters and we don't return anything, but notice that this is in green now and it's specifying, hey, person.hello is going to be equal to a function. So what I can now do is specify hello, and we can make this equal to a function. And this function can say something like console.log, and then this dot name plus says hi. Okay, you don't have to understand this too much in depth, but I'm just showing you that we can have a function. And now if we come down here, we can say something like person.hello, and if we call that function, that is going to print out Tim says hi. Okay, so that's it in terms of adding different functions here. Now let's look at some more advanced examples of interfaces. So let's say we have this person interface here, and we have another type of object we want to create that's very similar to this person interface, but maybe has one or two different methods. So it is a person, but it might have some additional things that we want to add on it. In that case, we can create a new interface, and I can say interface, maybe something like employee. And then we're going to say that this extends the person interface. Now, when we extend an interface, what we're doing is we're inheriting all of the different properties that exist here, and then we're adding any additional ones we want. So I can add something like employee ID and make this a number. And now if I go down here and I make an employee, so I say const, let's go worker is of type employee, sorry, and is equal to an object, you'll see when I highlight over this, I need to add all of the following properties: employee ID, name, age, and hello. Now let's just remove hello because I don't want to define that. Let's add our name of Tim, our age of 23, height 175, and employee ID of 10. And now this is proper. We have an object that implements the employee interface. That means it has all of the different properties. Now we could actually go a step further here, and we can actually extend multiple interfaces. So let me quickly show that to you. So let's say I have another interface here, and we call this manager. Now this isn't going to be the best example, but it will at least illustrate what I'm trying to show you. So inside of the manager interface, we have employees, and maybe this is going to be actually an array of people that this person manages. Now from the employee interface, what we could do is we could extend the person interface, or from the manager interface, we could extend both the employee and the person interface. In fact, let's do it that way. So let's go here and we say from the interface manager, we are going to extend the employee and the person. Now in this case, it's a little bit redundant because since the employee already extends the person, there's no need to do this. But let's say employee did not extend person. What I'm doing now is specifying, hey, we're extending both the employee and the person interface, which now means we need all of these different properties for something to actually adhere to this interface. So if I come down here and I say const manager of type manager is equal to an object, and we hover over it here, you see that we need employees, employee ID, name, and age. Those are the properties we need to specify for this to successfully implement this interface. Okay, so that works well. Now I'll quickly show you that when we use the interface, we can use it in many different instances. It doesn't have to directly be for the type of a variable. For example, a lot of times we may do this in a function. So let's say function get person, and we may take in actually a person and return a person, something like that, right? And we can just return, and then we'd have to return an object that adheres to this interface. So we'd say name, Tim, age 23, and now this is valid. The point is here that we can actually make our parameter quite a bit simpler by using an interface rather than say taking all of this and pasting it here, which is actually valid to write out. Instead, we store it in an interface, and now it's a lot easier for us to read what it is that we're actually taking in. And if we want to see all of the fields, we can go and directly look at the interface. So that's about all I had to show you with interfaces. They're not overly complicated, but just remember that you use an interface when you want to type an object that has different properties. Anything that adheres to the interface or implements the interface must have all of the mandatory fields defined, and you can use the interface as a type in any place that you could use any other type in TypeScript. Another thing to remember is that interfaces can extend other interfaces or multiple interfaces, and that's going to just do an inheritance of all of the different properties. So with that said, that's all I had for you. I'm going to wrap up the video here, and I look forward to seeing you in the next one. Hello everybody, and welcome to another video in this TypeScript course where we're going to be talking about classes and objects. Now most of what I'm going to show you here you've already seen. The main difference is going to be in how we type our classes and some keywords that we can use with TypeScript. So let's begin by defining a simple class. In fact, to save us some time, I'll just copy one in here and we can have a look at it. So this is a person class, and this is similar to what we set up in the previous video, but simply using an object. You can see that we start by defining the different properties that we want to have for each instance of our class. In this case, we have a name property. We then have a constructor. This will be called when we create a new instance of this class. And then we have a method or a function. This is greet. This is simply a void function. If we hover over it, you can see it returns void. That's it. That's our class. Now with this class, there's a few things that we can do to add some TypeScript types to it. For example, for our different properties here in the class, we can add some keywords before them that define whether they are public, private, or protected, and I'm going to explain what that means in the context of a class. First though, let's create a new instance of this. So we'll say const p1 is equal to new person. Okay, and we need to pass a name, so we'll say that this is Tim. Okay, so we've just created this person class. That's great. Now let's see what happens when we start changing and adding what's known as an access modifier to our property. We can also do this with methods, and you'll see how that works. So before our method name here, it's possible for us to add something like private. Now when we do that, what that actually means is that this property here can only be accessed within this class. Now to show you that, if I do something like p1, notice that I'm not actually able to access the name property. The reason I can't do that is because I've specified what's known as an access modifier on the property of private. Now by default, if we remove this, the property is going to be public. That means that anything can access this and we can change it and modify it throughout the program. Now you may be asking yourself, well, what's the point of making this private? Well, the point of making it private is that sometimes we have some internal state that's a part of our class that we don't want to be modified or accessed by anything outside of it. So the idea here is essentially to more safely write our classes by making something like this property private. This pretty much tells everyone else who's interacting with the class, hey, don't change this, don't mess with it. We should only be changing it from inside of the class. And in some more advanced examples, that does actually make a lot of sense to be doing. That also means that once I've created the name here, so I've passed that into the constructor, we can't change that name unless we do it directly through the class by calling something like a method. This means we can actually add what's known as a getter method or a setter method inside of our class that allows us to kind of gate the access of this property. You may have seen this convention before, but for example, we might have a method called getName. And what this will do is simply return this.name. Now inside of the class, it's perfectly valid for me to access the name property because it's inside of the class, even though it's private. It just simply from outside, I can't access it. So now what this means is if I call p1.getName, I can actually access this name, but what we've done is we've kind of gated it behind this method, which means if I wanted to do something like, if this.name is .length, for example, is less than 2, then return an empty string. So maybe we have some kind of condition, right, where we're gonna return a modified version of this name and we have more control over it because we're allowing the person to access it, but only through this specific method. I'm hoping this makes a little bit of sense. Now we can do the same thing with something like a setter. For example, we may have a method here called setName, and this might take in a name, which is a string. Now in this case, we could do a similar type of thing where we say if the name that's passed in here .length is less than 5, then maybe we return. And the reason we'll return is because we're not going to allow you to set the name unless you give us a name that's at least 5 characters. If you did give us one that's 5 characters, then we could say this.name is equal to name, and now we can only access this name property, which is private, by using the getter and the setter. Okay, so that was a little bit of a tangent there, but I just wanted to show you the first attribute or the first access modifier, which is private. Now, as well as private, we have public. Now this is what it is by default, so you don't actually need to write out that this is public, but when it's public, that means even outside of the class, we can access this attribute. So I can do something like p1.name is equal to Joey. Perfectly valid, that's fine. Now we also have one other one, which is protected. Now, protected is a little bit different, and what this means is that either this class or anything that inherits from this class can access this property. So outside of the class, I still cannot access name. However, if we have a class that inherits from this class, within that class, we are able to access this property. So let's look at a quick example of that. We're going to have class employee, and this is going to extend the person class. And then inside of here, we can do something like call me, and this function could say console.log, and then this.name. This is perfectly valid. We're able to access the name property from the base class or the parent class inside of a subclass. It's just from the public scope here, so anything outside of the subclass or the base class where we can't access a protected property. So a little quiz here, or a little recap, I guess, private, only the class can access it. Protected, this class and any subclass can access it. And then public, anything can access it. You want to use the strictest access modifier you can. So if it doesn't need to be public, make it protected. If it doesn't need to be protected, make it private. And you can do this not only for different attributes, but for methods as well. For example, I can actually specify this as private. Now, when I do that, what that means is that I can only access this from inside of the class. Now, the reason why you would make something private is because this is a method that should only be called internally. So let's just get out of this example here. For example, what I might be doing is saying this.greet. Now, in this case, this actually makes sense because what I'm saying is, okay, inside of the constructor, as soon as I initialize my name, I'm going to call this.greet, but I don't want to allow someone outside of this class to be able to call this method. It's just meant for internal use, so I add the access modifier of private. Again, we're just restricting access and we're making it so that someone can only use the attributes that we define as public or protected. And this also avoids confusion, because if we had a bunch of methods here that weren't private, but they were only meant to be used internally in the class, someone could accidentally use one of these methods and mess up some of the state of our objects, which we don't want. So now you'll see if I go down here, I can't actually call the greet method. And if we hover over here, it says it is private and only accessible within the class person. Now we can change this to be protected. If we make it protected, same deal as the attribute, we can now access it from a subclass, but again, we can't access it from the public scope. By default, even if we don't write it out, this is going to be public. So you don't need to actually put public there. Just by default, when you write a function, it will be public access modifier. All right, so that covers the access modifiers, which are the most important thing to understand. Now what we want to talk about is abstract classes. Now, an abstract class is something that is not meant to be instantiated, but is meant to act as a base class for some behavior that needs to be implemented. You'll see what I mean as we go through an example here. But let's say we have an abstract class, which is an animal. Now, when I define this class as abstract, what that actually tells me is that we cannot create an instance of the animal class. We can use the animal class, we can extend it, and we can override functionality inside of it, but we can't actually instantiate this. So if we go here and we say const animal equals new animal like that, you'll see that we actually get an error, and it tells us that we cannot create an instance of an abstract class. So I just want to make that really clear. An abstract class is meant to act as a base class that will be inherited from by a subclass. So inside of here, what we can do is define something like a method. So let's say inside of our class here, we have something like this, where we say move. Now inside of the move function, we might do something like console.log and then moving along, ... We then also may want to call some other method, but that method may not actually be defined. I know this is really weird, just bear with me and you'll see what I mean. So what I'm going to do here is define an abstract method. So I'm going to say abstract make sound, and this is going to take in, let's go duration like this, which is a number, and it'll just return a void. Now what I've done here is I've said, okay, I'm having an abstract class animal. This abstract class can never be instantiated. Now what that means is that inside of this class, I'm allowed to define something known as an abstract method or an abstract function. Now what I do here is I pretty much define something that must be implemented by a subclass of this class. Anything that inherits from this abstract class must implement the behavior for this specific method or function, whatever you want to call it. Now, the reason I define this inside of the abstract class is there may be a concrete method, something that actually has an implementation that needs to use this abstract method. So to show you an example here, I may actually call this dot make sound, and I may pass this some duration. Now let's just say duration number, and we pass the duration. So what I'm doing is saying, okay, we have this abstract class. We know that it's never going to be instantiated, and anything that inherits from this abstract class uses as a base class must define this make sound method. That means that inside of this concrete method, I can rely on this being implemented because I know something must implement it. So I've said I have this method that anything can call. This is some functionality that we may reuse across all of our different subclasses. In here, it prints out moving along, and then it calls this dot make sound, which will be different for all of our different subclasses. So let me show you an example because again, I know this is very abstract, no pun intended. Okay, so we're gonna say that we have another class here. So this will be class dog extends animal. Now notice right away when I do this that it gives me an error, and it says non-abstract class dog does not implement inherit abstract member make sound from class animal. So it's telling us exactly what I told you. Whenever we inherit from an abstract class, we need to implement any of the abstract methods so they can be used by the concrete functionality built into the abstract class. So in this case, I can say make sound, right? I can define this, and it needs to have the same call signature as the abstract method. So I'm going to say duration number like that. And then what we'll do here is we'll just say console.log and then woof, woof. So now if I make a new instance of my dog, so I say const dog is equal to new dog, I can say dog dot, and then notice I have two methods that I can call. So I can call the move method if I pass a duration. So we can pass something like 10, even though we're not using this, don't worry about it, but we can pass that. So we say dog.move 10, and then what this is going to do is call this, which is the implemented behavior from the abstract class. It's then going to say console.log moving along, and then it's going to use whatever the method is that we've defined here. In this case, it's make sound to actually print out woof woof. The reason why this is cool is because now if I make another class, okay, and I call this something like cat, I can now change this. So rather than woof woof, we would say something like meow meow. Right? So the idea here is now that I can use this move function, and based on the subclass that's inheriting this abstract class, we're going to get some different behavior that's reusing this base functionality. I know this is pretty complicated, and this is something that we should have looked at more in the object-oriented programming section. Fortunately for you, this isn't critical. You don't really need to understand this a ton, and you're not going to use it too often, but I wanted to show you this syntax because it is something that you may see. So again, we have an abstract class. The abstract class can define different abstract methods. We can have more than one method, right? Like I could define another one here, make sound 2. And if I do that, now each of these need to implement make sound 2 as well. The idea is that any abstract method is typically going to be utilized by a concrete implementation in the abstract class. So we need to define that functionality when we inherit from that class so that whatever the functionality is that's already defined in the abstract class will still work, because it relies on the fact, and sorry, I just shot my mouse off my desk here. It relies on the fact that this abstract method will be implemented by the subclass. All right, that was a lot of words. Those are big, complicated words, and they are difficult to say and explain very clearly. But that is abstract classes and the basics of using TypeScript with classes. Remember, you have your access modifiers. Those are the most important: private, public, and protected. You should know what those are and how those work. You should also know when to use each. Private, when you want to essentially hide the internal state and you don't want to allow someone else to access it. Protected, when you want to allow subclasses to be able to access it. And then public, when you want anything to access it. If you make something private or protected, oftentimes you will create what's known as a getter or a setter that gate the access to that specific method, so it can still be modified from outside, but it needs to go through some certain checks or constraints like we looked at. With that said, I'll wrap it up here, and I look forward to seeing you in the next one. Hello everybody, and welcome to the next video in this TypeScript course. In this video, I'll be talking to you about classes implementing interfaces. Now, I know there's quite a bit of terminology here. Again, you don't need to memorize all of this. I just want to make you aware of it in case you see it in TypeScript code. It's not often you're going to actually be writing all of this yourself or even need to use it, but it is kind of a core computer science concept, so I think we need to go over it. Okay, so in the previous example and what we've seen before is that classes can extend other classes. Now, when we extend and we use this extends keyword, we're inheriting functionality from another class. The reason we do that is because we may have similar functionality that we want to inherit, right? We don't want to rewrite the code 6, 7, 8 times across all of the classes that need it. We create that one base class. It can be a concrete class or it can be an abstract class, and then we inherit from that class by extending it and adding the customized functionality we need for an individual class. Previously, we saw that we had some animal, and then maybe we had a dog class, and we had a cat subclass, or we had a person class, and then we had an employee class or a manager class. We were reusing that functionality. Here, I'm going to show you something a little bit different, which is implementing an interface. Now, an interface is abstract. What that means is that it doesn't actually define any functionality or behavior. Different from an abstract class that can have some abstract methods and some concrete methods, in this case, every method we have is considered to be abstract or non-implemented. When I say abstract, what I really mean here is that we define it, we write it out, we declare that it should exist, but we don't implement all of the functionality. So in this case, we say, yeah, we're going to have a function speak, it returns void, but we don't actually implement what that function is. So with these interfaces, we can use them for objects, but we can also use them for classes. And this makes sense, right? Because if an object can implement an interface, so can a class, because a class is really a blueprint for creating different objects. So let's create a class now that implements this interface. I'm going to paste one in just to save us a little bit of time. Now this is the dog class. And what I want to do is I want to specify that it is an animal. Now for it to be an animal, it needs to specify the different methods that are on the animal interface. So the way I do this is the following. I don't say extends, I say implements the animal. Now when we implement an interface, that means we define any of the methods or properties that exist on the interface, just like we looked at before when we were looking at standard objects. So in this case, I need to define a speak method. So I'm going to say speak like that. And one thing to remember here is that all of the methods that we're declaring inside of our concrete class, so in this case dog, need to be public. If I try to make it private, we're actually going to get an error here, and it's saying, hey, class dog incorrectly implements the interface. Property speak is private in dog, but not in type animal, because by default, these are all going to be public that are in the interface. And you're going to see why that's important in a second. So inside of speak, maybe we do something like console.log, and we can do some backticks here and say I am, and then whatever the name is, so this dot name, and I am, and then we can do something like this dot color. Okay, so there you go, we now have the speak method. Now what this allows us to do when we implement this interface is it allows us to view this class through the lens of this interface. Now in order to make this clear, we're just going to add an additional method here. We're just going to say test, and all this is going to do is just return 1. Okay, and let's zoom out a little bit so we can read this. So first thing you notice here, it's valid to add additional methods. We can add additional properties, methods, etc. It doesn't matter so long as we have whatever is specified in the interface at minimum in the class. So now what I can actually do is I can create a new dog. I can say const dog is equal to new dog. I need to pass in a name and a color here for my dog. Let's zoom out one more time just so we have a bit more space. Okay, so now if we look at this, we see that this is of type dog. And if we look at dog, we have the ability to call the test method and the speak method because those are what are public and that's what we can see. But I want to show you that what we can actually do is we can type dog as if it was an animal. Now when I do this, notice that when I hover over dog, it tells me the type is an animal. And when I try to start accessing the properties on my dog, notice that that test method has gone away. Instead, we just have speak. Now the reason for that is what we've done is we've just viewed this dog through the lens of the animal interface. Since it implements the interface, we can treat it as if it's an animal because we know this behavior exists, but when we type it as an animal, we only know that whatever's on animal is there. So we're not able to use the test method or anything else that exists on dog because we're viewing it through the lens of the animal. Now this is intentional, and sometimes you want to hide the complexity and the functionality of this specific class, and you instead want to say, hey, I only care if it has this specific method, so I'm going to type it as an animal. Now this makes more sense in function parameters, which you're going to see in a second, but I just wanted to show you that this works. Okay, now let's create another class and see what happens when we use multiple classes implementing the same interface. So let's say I have class cat, and this implements the same interface, which is animal. Now notice again, it's going to tell me that I need to declare the speak method. So for speak, I'm just going to say speak, if we spell that correctly. And then inside of here, we're going to say console.log, and we're just going to say meow. Much simpler than dog, but it still implements the animal interface. Now what's interesting here, if I come down, is I can say, let's do our dog again. It's equal to a new dog. I should have actually kept that there, but that's fine. This will be Tim and Brown. And then I can create my cat, const cat is equal to new cat, like so. Now this is the dog type, this is the cat type. However, watch this. I can say const animal is equal to dog, and this is perfectly fine if I type this as an animal, or I can say const animal is equal to cat, and this again is perfectly valid. What I'm doing is I'm viewing both the cat and the dog as if they were the same object because they both implement the same interface. I'm going to go a step further here and show you why this is actually useful. So let's say we have animals and we actually want to store an array of animals. Well, what I can do now is I can specify my cat and my dog inside of the array. And even though these are different types, right, this is a dog and this is a cat, since they both implement the animal interface, it's possible for me to view them as if they were the same type and treat them as if they were an animal. Now what that means though is when I start using them, so I say animal 0 dot whatever, I can only use the methods that are defined on the animal interface. Now why is this important? Well, sometimes we have something like a function, right? In this function, let's call it make sound, and what we'll do is we'll take in an animal. And what we'll do is we'll say animal dot speak. Now in this instance here, all this function cares about is that we have something that implements the animal interface. It doesn't need to be a cat, it doesn't need to be a dog, it doesn't actually care what the object looks like so long as it has the method here, speak, that implements this interface. So now what this allows me to do is have a more flexible function that can take in any type of animal regardless of its actual implementation. So I can say make sound and I can pass the dog. Or I can pass the cat. It doesn't matter. I can pass either or because they both implement that interface. So the idea behind interfaces is you are essentially increasing the abstraction of your program, and you're making it so that we don't care about the finite implementation details of whether something's a dog or a cat. We simply care that it implements the behavior we need to use, and then we can treat many different objects or many different classes as if they were the same thing. So that's what we do. We look at an object through the lens of a specific interface. So interfaces allow us to group different things together, to treat them as if they were the same object, and to hide the complexity that we don't care about. Rather than doing this, you might say, okay, well, for the animal, maybe we do cat or dog. I mean, this is valid, but the issue is now, if we have something else that adds the speak method, we now got to go in here and we got to add that. We don't want to do that. Instead, we just say, hey, animal. Now, anything in the world that implements the animal interface works and is valid inside of this function. Okay, so that's the idea here with interfaces. Now, we'll quickly talk about when to use an interface versus when to use something like an abstract class or a base class. You use an interface when there's no functionality that you want to define concretely. So in this case, animal's not defining anything or implementing anything that both dog and cat are going to reuse. It's simply saying that anything that is an animal must have this, but it's not defining something that's going to be used by all animals, right? It's not defining some reusable function. Now, this is where it differs from an abstract class. With an abstract class, typically you are going to be writing some kind of behavior that will be reused by one of the concrete classes. So we saw in the previous example, we had that abstract animal, and it had that one function that we actually did write out, and then it had an abstract function. So that's when you would use the abstract class, when you have some concrete functionality that is going to be reused. When you don't, instead you're going to use an interface. Now, if you have no abstract classes or no abstract functionality that needs to be implemented, you can just use a normal base class. You don't need to go with the interface or the abstract class. Again, the idea here is when we make this, it simplifies our program and it allows us to treat different objects as if they were the same type, making things quite a bit more flexible and allowing us to only have to worry about the type of behavior that we care about in a specific implementation. So that's going to wrap up this video. I hope you found it helpful, and I look forward to seeing you in the next one. Hello everybody, and welcome to the next video in this TypeScript course. In this video, I'll be going over the static keyword. Now, the static keyword allows us to create static attributes and static methods, which are simply variables and methods that are associated with the class rather than with each instance of the class. Let me show you what I mean. So we have an example here where we have a class dog. Now we have an attribute name, and this attribute is an instance attribute. That means for each of our dogs here, they have a different name. Now, what differs is when we use the static keyword, we instead are going to create an attribute that's associated with the class, not each instance. So let me show you what I mean. We can say static instance count. This can be a number, and we can make this equal to 0. Now we simply prefix this with static. And now we have this variable which is associated with the class itself. So what I can do is inside of my constructor, I can say dog.instanceCount++, and what we've now done is set up a variable that actually tracks the number of instances of the dog class. So here the instance count will be 1, and then here the instance count will be 2. However, we'll access the instance count using the name of the class, not each instance. So for example, if I go here and say console.log and then dog.instanceCount, and we can do this twice. let's bring up our terminal. If I can drag this here, let's compile and let's go node app.js. You'll see that we get 1 and we get 2. Now again, the reason that's the case is that this exists on the actual class, not each instance. So it's the same for every single one of our instances because it's really associated with the class itself. Now you may be asking yourself, well, why would you use a static attribute? Well, obviously this is one example where you want to track the number of instances that exist. Another example is when you have some variable that belongs inside of the class and will only be used inside of this class, but isn't different for all of the instances. So maybe it's a shared value that all of the instances want to always have access to. If that's the case, then you would make a static variable or a static attribute. Pretty much whenever something belongs inside of the class, but it doesn't need to be an instance attribute, you can make it a static attribute like I showed you here. And you can have as many static attributes as you want. Okay, now as well as that, we can actually have static methods which work in a similar way. So for example, we can do something like static and then maybe decrease count. And inside of here, what we can do is say instance count minus minus. Now in this case, we can use this static method the same as we use the static attribute. So I can go here and say dog dot decrease count like that, and that's going to decrease the count. And now if I take my instance count here and we go up and we run this, oops, I need to compile first and then run, we get 1, 2, and then 1 because we've decreased the count. Now, one thing to keep in mind here is that these static methods can only access variables that are associated with the class. So in this case, static attributes or static variables, whatever you want to call them. Now, that's why I was able to use the this keyword here, because when I do this, it's referencing the class dog. It's not referencing an individual instance. The reason that's the case is because we know that our static methods can only be called by the class itself. So I use dog dot, right? So dog dot decrease count. So this references the class that I'm actually acting upon. Now I could write dog here as well, that would be valid, but I can also use this. Whereas here, when we look at this is simply an instance of the class that we're acting on, where this is the class itself. So that's kind of it for the static keyword. You can create static methods and you can create static attributes. Again, these are associated with the class. They're the same for all of the different instances. They are different than a normal attribute like an instance attribute that I showed you here. You may not use them too often, but in case you see this static keyword, that's what it means. It does not have access to any instance information. It's simply something stored within the class associated with the class itself. So with that said, I'll wrap up the video here. I hope you found this helpful, and I look forward to seeing you in the next one. Hello everybody, and welcome to the next video in this TypeScript course. In this video, I'll be going over generics. Now before we even talk about generics, I want to show you an example of where we'd want to use one, and you'll see why it's useful. So have a look at this data store class. What this allows us to do is simply store a bunch of values, in this case, store a bunch of numbers. Now the way we would use the class is something like this. We would say const data is equal to new data store. We initialize the data store, and then what we can do is add items to it, get items, remove items, and then get all of the items. Now this is very similar to a normal array. However, in this case, it only works on numbers. That means that I can say data dot get item, and I can try to get item at index 0, but I can't do anything with a string or any other type of value. Now I know that we could simply do this with an array, but let's imagine there was some more complex behavior here, and we did actually need a class to implement this type of behavior. Well, now we're able to do this with numbers, but what if I want to do this with strings? What if I want to do this with objects? What if I want to do this with a more complex type? Well, what I would have to do, if we don't know about generics, which we'll talk about in a second, is we would have to copy this. We'd have to call this data store for string, and then we'd have to change all of our types here to be string. That's obviously not ideal, and that doesn't make any sense when really the only thing that's going to change inside of our class here is the type that we're using. So really, we need a way to variably be able to pass in the type and use a different type based on the instance of the class that we need. Now this is where generics come in. What we can actually do here is we can specify that this is a generic class that uses type T. Now you do that by putting a set of angle brackets and then a variable that will actually represent the type that you're going to be using. So what we'll do now is when we instantiate the class, we'll pass in some type, which will be the type that we're going to use throughout this class. We'll change a few things here in a second, but for now we'll say new data store, and then we can do something like string. So now what I'm doing is saying, okay, well, when I create this data store, I'm specifying that the data type I want to store is a string, and now I'll use t in place of all of my numbers. So I'm just going to go Control F. I'm going to replace a number with type t, and you'll see now, oops, this needs to be number still, and actually this needs to be number as well, that now everything is still working. We're not getting any type errors. So we've pretty much passed in a variable, which is type t. So now we've created a new data store, which is of type string. But we could even go a step further. We could make an interface called, say, user. We could have name, which is a string, and maybe ID, which is a number. And now we could create a new data store, and we could actually do that with the type user. It doesn't have to be a primitive type. It can be any type that we want. So we're able to use t as if it's any other type when we pass it in generically using this generic syntax. Hopefully that makes a little bit of sense, but I'm just trying to illustrate that now this class works with any data type that we like because it's generic, and we can create all kinds of generic things. In this case, our different functions are using the generic type, so we're returning an array of whatever the type of this data store will be. This gives us the strong typing, but gives us that variable component where we now can reuse this class for any type that we like. Now let's clear all of this and let's do an example of using maybe a generic function or doing some more advanced generics. So let's write a function here and let's call this getValue. And we're going to make this generic by taking in two data types, k and v. Now we're going to take in some key v. We're going to take in value1, which is v, and sorry, this needs to be of type k. And then we're going to take in value2, which is also of type v, and we're going to return a v. Now what we're saying here is we're going to say if the key exists, so if the key is some value, then return value1. Otherwise, we can go here and we can return value2. Now, pretty much what we've said here is, okay, we're going to have a function called getValue. This is generic, and it can take in a type of k and a type of v. So this key will have some type, and then the two values will be the same type and will return one of those values types. I know, seems a little bit confusing, but all we're doing is having two generic values here. Then inside of the function, we're just checking, okay, does key actually exist? Is it a truthy value? If it is, we return value1. Otherwise, we return value2. So now to use this function, we can say getValue, and I could pass in some string like hello, and then maybe 1 and 2. Now this is completely valid so long as the two types that we pass here for value1 and value2 are the same. And then we know we're going to get back, in this case, either 1 or 2. If we wanted to make this a bit better, we could say const number or const n1 number equals 1, const n2 number equals 2, and then we could say n1, n2 like that. And now if we look at this, you can see that the function now is a generic, which has a string and a number, and then it simply returns a number, okay? Now in this case, we don't need to manually specify what the generic is because it can be implied based on the values of the parameters, but if we wanted to be more explicit, we could actually just write out, hey, we're gonna call this getValue function, and we're gonna use string and number as the two generics, and then we pass in our string and we pass in our two numbers. Okay, so that's pretty much it with generics. I know they can seem a little bit intimidating, but you're pretty much just creating a variable, or in this case, a parameter for the data type that you want to use. That previous example I showed you is great. It allows us to have more flexible functions, methods, classes, etc. that can accept any different data types, and then you can simply set when you want the data types to be the same for the different operations you're performing. Again, gives us a lot of flexibility, and this is quite useful, especially when you're writing more general classes or things that could be used by all different types of objects. What's funny is that JavaScript actually has some generics built into it that you may not even know about. We don't need to talk about that right now, but in many programming languages, a lot of the classes you end up using are actually generic, and they are that way for the fact that they can be quite flexible and you can use them with really any type. So anyways, with that said, I'm going to wrap up the video here. I hope you found this helpful, and I look forward to seeing you in the the next one. Hello everybody and welcome to the next video in this TypeScript course where I'm going to be going over type aliases. Now a type alias is a way to essentially create a custom type that is something other than the mapping for an object. So we looked at interfaces before, and interfaces are really used by classes and by objects. We can extend them, we can implement them, we can have a class implement them. In this case though, we're going to look at something different, which allows us to create our own custom type for non-object based types. I know that seems a little bit weird, but just bear with me as I get into this example. So let's say we're writing some function and we're going to call this compare chords. Now what we're going to do is take in P1, which will be a tuple of number and number, and then we'll take in P2, which will also be a tuple of number, number. Then we're going to return a tuple number, number like that. We're going to write the function body, and we're going to format this so it's a little bit easier to read. Inside of here, we're going to return something quite simple, just P1 0 and P2 at 1. Doesn't make a ton of sense, but we're just writing a function for example purposes here. Now what you may have noticed is that we're using a slightly more complicated type here for the type, for the parameters, as well as the return value. And we're kind of repeating this type 3 times. So what I can do instead is I can create something known as a type alias. I can say type, I can call this something like coordinate, and then I can just specify what the type is that I want to store in this alias. Alias just means another name. And now I can start using this in place of that tuple. So I can take my coordinate, I can paste this here, and now you see that we've created a type alias for the coordinate type. This really behind the scenes is just a tuple of 2 numbers, but we now kind of simplified it, stored it in this variable, and we can use this anywhere in the program that we want. Now where this becomes even more impactful is when we start using this in combination with other custom types or with complex types that we write. So for example, I might create a variable called chords, and this might actually be something like an array of coordinates, right? So now we've been able to use this coordinate type, and it's a lot easier for us to understand and read how this works, as opposed to if I were to say number, number, like that. Now there's a whole bunch of uses for type aliases, but typically we use them when we want to define something that isn't necessarily an object. So you saw previously when we used interfaces, those were really designed for objects and specifying the properties that an object will have. Now we can do the same thing with the type here. So what I can do is I can go here and I can say something like name string and age number, and I can add my methods or whatever I want. And that's totally fine. It's valid for me to do that as a type. But in this instance, since we're trying to really map an object here, instead we would most likely just use an interface. We don't need to actually make that a type. So it makes more sense when we are working with objects to be using an interface, and when we're working with non-objects, so in this case we're creating a more custom type that's maybe more complicated, we simply use the type constraint, or in this case the type alias. Now there's a bunch of differences between interfaces and types. For example, we cannot implement the type, we can't extend the type. So if we're working with classes, we can't write a class, so like class dog, implements, let's write it here. Coordinate, this just doesn't work. It's not valid syntax. You'll see it incorrectly implements the interface number, and we can't really do that using the syntax that I have right here. So if you do want to be working with classes, you're going to be making an interface, and when you're making your own custom type, typically as a shortcut, you're working with the type alias. Now in the next video, I'll talk about a few other differences when we get into the intersection and the union, because that's where this becomes a bit more useful. But I wanted to quickly show you this convention here. So we've created this type coordinate, and I mean, we can make other types if we want. We could say type something like list, and maybe this is just going to be, a nested array of strings. And then if we really wanted to here, right, we could combine these types together. We could use them in a more custom type. You can get as complex as you want, but the point is it's just an alias for something that's not necessarily an object. Okay, and that's all I had for this video. I will see you in the next one. Hello everybody and welcome to the next video in this TypeScript course where I'm going to be going over the union and the intersection types. Now union is the pipe operator and intersection is the AND operator, if I can type this correctly, and this allows us to combine multiple types together to create some more complex types. We've already seen the union operator a bit, but I'm going to talk about it more in depth in this video. So let's begin by actually creating a type that uses a union. So I'm going to say type, and this will be string or number. And here we'll simply say string, or in this case, it's the union operator, number. Now all this is doing is allowing us to have either the string or the number. We're just unioning them together, which means it can be one or the other. So it's not both of them, it's one or the other. Just make sure you know that. Now we can union multiple together, so I can have string or number or Boolean. That's completely valid. And I might want to use this to say a parameter for a function or something, right? So I'll say function accept val, and we'll just say val, and this can be the string or number, and then we can do whatever we want, and we can see here that this is a string or a number or a Boolean. So again, we've used the alias because it's a little bit nicer than taking all three of these values, and pasting them inside of the parameter. So now that we've looked at the union type, let's put in an example to look at the intersection type. So let me just format this so it's a little bit nicer. So let's say we have two interfaces, the business partner, and the contact details. And we may want some type that actually has the combination of both of these interfaces. Now we could make an interface that extends both of these, but instead what we can do is make a type. So we can say business contact is equal to something like the business partner and the contact details. Now when we do the and, this is the intersection, and now you'll see if I try to create something here, so I'll say const contact, and we make this the business contact. So here we would need to have the name, so say something like Tim. We would also need to have the email, so tim@gmail.com. Not my actual email, by the way, so don't send an email to that. And then phone, and we put some phone. Now you see that we no longer get the error message because we implement all three of the properties that come from both the interfaces. So in this case, we used a type alias because this isn't representing an object. This is representing the combination of two other types. So now we use this type, right, if we want to have something that implements both of these different interfaces. So we can now use this inside of a function parameter. We can use it wherever we want, but this is kind of the difference again between the interfaces and the type alias. With the interface, we're defining the shape of an object typically. With the type, we're typically creating a more complex type, and we're storing then some kind of alias that we'll then use later on in the program. So now let's look at a quick example of kind of combining some of these unions and intersections together. So let me copy in another brief example here. We can run our format, and you see that we have the individual and we have the organization. Now what we can do is make a type here. We can say type contact type is equal to an individual or an organization. Okay, then we could create another type here, and we can call this the contact, standing for comprehensive contact, and this could be the individual and the organization. Okay, so just a difference here, right? This is doing our union, this is the intersection, this is this type or this type, this is this type and this type. Now what we can do is something like function add contact, and maybe we have some contact here and we take in the contact type. Now when we do this, we can see that for the contact type, that is either an individual or an organization. It is not both. Now inside this function, let's say we want to handle one of the potential types that could be coming in here. I can say something like if birthday is in the contact, then I'm going to do this. Otherwise, I'm going to do this. So I could say console.log, and then we could log something like the contact.name and the contact.birthday. Otherwise, we're going to console.log the contact.company name and the contact.workphone. Now notice what I actually did here is I checked if one of the properties is in this contact. So when you use the in operator, you're checking if this exists as a property on the object. So we're saying, hey, does birthday exist on the contact? If it does, that means that we must be an individual. Otherwise, we must be an organization. So you notice here when I started doing my autocomplete, right? So contact, it shows me work phone, and it showed me the company name because it knows that in the else statement here, we must be dealing with an organization, whereas up here, it knows we must be dealing with an individual. Okay, that's pretty much it. There's not much more to go through here. This just shows you how you can check one type or the other and how you can combine two types together. Remember, interface for objects, types for more complex types. With that said, I'll wrap up the video here. I hope you found this helpful, and I look forward to seeing you in the next one. Hello everybody, and welcome to another video in this TypeScript course. In this video, I'll be talking about type guards and type narrowing. Now we've seen all of this already, but I just wanted to formalize it into a single video so we can understand exactly how it works. So type guards are really just a way for us to check what type a specific value is before we start operating on it. Now we've already seen most of the type guards that we can use, but for example, the keyword type of, this is a type guard because we can check what the type is using it. The keyword instance of, we can use this again to check the type. We have in, we can use this to check the type as well. There's a bunch of other ones that we can use, but those are the main ones. Now the main idea is that we use a type guard to provide something known as type narrowing. Now type narrowing allows us to take a type that's maybe more general. So for example, we could type, string or number, right? So this could be string or a number, and we can narrow the type into more concrete types. So rather than being string or number, we narrow it to just string, or we narrow it to just number. So a basic example of writing a type guard could look something like this. We have function, and we'll just do something like add 1, okay? And then we're gonna take in a value, which is a string or a number. And then we're going to return, in this case, actually, what do we want to return? Well, we can return a string or a number as well. So we can just make it this type, string or number. Okay, so then we can provide a type guard here. So the type guard is just narrowing what the type is. So we can say if the type of, if we spell that correctly, value is equal to a string, then we're going to return the value plus the string 1. Otherwise, we're going to return the value plus the number 1. Okay, so we've just written a type guard. The type guard is using the type of keyword, and we've narrowed the type. So we know here that this is going to be type string, and we know here that this is going to be type number. So that's one way to do it. Another way to do it is to use instance of. So let me kind of whip up a quick example here and then show you how that one works. All right, so let's look at this example here where we have a dog and we have a cat. Now in the dog class, we have a first name and a last name. And in the cat class, we just have a first name. So actually, let me remove this from the constructor. Now we have some function getName, and it takes in a cat or a dog. Now what we need to do in order to correctly output the right name is we need to actually narrow the type down so we know if the animal is going to be a cat or if the animal is going to be a dog. Now, there's a few ways that we can do that. The first way is we can say if animal is an instance of, and then we can say the cat class, then we can console.log, the name is, and then we can put animal.firstName. Otherwise, we can say console.log, and then the name is animal.firstName plus a space plus the animal.lastName, right? So all we're doing here is we're type narrowing again. This time we're using the type guard of instance of. It checks if the animal is an instance of cat. So here you can see that it says it's a cat, and here it must be a dog. So we've used instance of. Now I'll show you a way that we can change this to use the is keyword. Now this is going to be a little bit different, but we can say something like last name, and then this is not in cat, this is going to be in animal. And then we can just switch our lines here. So we'll say, okay, well, if that's the case, we can print this out. Otherwise, we can print this out. So let me just format this. Okay, so what we're doing is we're checking if the property last name is in the animal. If it is, that means that we're able to access the last name property. And you can see here that it's actually done the type guard for us, or it's done the type kind of narrowing. And now we see that this is going to be a dog, whereas down here, this is going to be a cat because we've checked if the property is in the object. Those are the three main type guards. We have type of, instance of, and then we have in. Now I want to show you one more keyword that we haven't looked at before, which is the is keyword. Let's have a look at that. So what we can do is use this is keyword to again provide some type narrowing and to check the type. Now we can create something known as a custom type guard function that uses this for us. So let me show you how this works. We can write a function and we can call this something like isCat. Now what we'll do is we'll take in a parameter pet and we'll call this dog or cat. Now what we'll do is we'll say pet is cat, like that, as the return value. I know this seems weird. And what we're going to do is return, and we're going to cast the pet as a cat, and we're going to look and see. Actually, we need to do this the other way around. Sorry, we're going to say is dog. We're going to say pet is dog. And we're going to cast the pet as a dog instead, if we can type this correctly. And then we're going to say dot last name does not equal undefined. Okay, so what have we just done here? Because I know this is a little bit confusing. We've written what's known as a custom type guard. Now, whenever you use the is as the return value here, what this is indicating is that you're going to return whether or not the value that's passed in here is a specific type. So in this case, this function is a type guard for dog, and we're going to return whether or not the pet is the type dog. Now, the way that we do that is we check for some type of value, in this case a property, that only exists on the dog instance. So in this case, last name exists on dog, but it doesn't exist on cat. So what we check is pet as dog dot last name does not equal undefined. So this omits giving us any type checking errors because we're casting it as a dog. And since we're checking if it's not equal to undefined, if this is actually a cat, when we cast it to a dog and we try to access the last name, it's not going to crash our code. It's just going to result in undefined. So if it is undefined, that means this is not a dog. If it's not undefined, it means it is a dog. So now we can change this. So rather than having if last name in animal, we can say if is dog, and we can pass in the animal, and now it's all good to go. And the reason why this is good to go is because we have this syntax here telling us that we're going to return if this is a specific type. So again, when we use this as the return value, this means we've created a custom type guard, and now we're checking if a specific object is a specific type. All right, that's pretty much all I had for you for type guarding and type narrowing. We've already looked at this quite a bit, so I think we understand the idea that we want to get to the narrowest type possible by, well, narrowing down all of the different types. Now we can do that using the type guards I showed you, like type of, instance of, in, and in this case we can use is, and we can write a custom type guard. With that said, I'll wrap up the video here. I hope you found this helpful, and I look forward to seeing you in the next one. Hello everybody, and welcome to another video in this TypeScript course. In this video, I'm going to be going over something known as the discriminated union. Now, this is an overcomplicated way of saying a tagged type. Now, you'll see what I mean here, but let's get into it. It's another way to perform type narrowing. So let's say that we have some interface, and let's call this something like warning, and then maybe we have another interface, and this interface can be maybe info, and then we have another interface, and this can be success. Now, all of these maybe have some kind of message associated with them, but maybe the term for it's a bit different. So for example, we might have message, which is MSG. For info, it might be text. And for success, it might be message, right? This is possible, especially if you're working with APIs. You might get some different types of results coming back. So here we go. We have warning, info, and success. And let's put them all in a type. So let's call this log, and this will be equal to a warning, or the info, or success. And the idea is maybe we have some kind of function, or maybe we're just going to be getting some type of log. We don't know if it's a warning, we don't know if it's info, we don't know if it's success. Well, we'd like a way to be able to narrow the type down so we can handle the specific field that we have, right? A specific property, message, text, or message. Well, how do we do that? Well, we could write a custom type guard, but instead we can actually use something known as a discriminated union. Now, this is essentially a tag or a property that's going to be the same for all three of our interfaces, but actually contain a value. So to show you what I mean, we can add something like type, and we can actually say that this is a warning. We can add type here, and we can say that this is some info, and we can add type here, and we can say this is success. Okay, so notice I've added a field or a property that's the same for all of them. I haven't given it a type, I've just actually specified a literal value, and now you'll see how we can perform type narrowing using this. So the easiest way to do this is actually just to write out a switch statement. So actually we need some variables, so we're going to say let log, and then this is of type log, and we're going to write out some kind of switch statement here. So we're going to say switch on the log dot type, which we know is going to exist on all of them. And then we can say that we have a case. The first case can be that this is an error, or what did we have? We had a warning, and then we can do something here. We can have a case, and we can say that this is info, and then we can do something here. And we can have a case, and we can say this is success, and we can do something here. Now it's giving us an error because we haven't yet defined log. So if we want to make this a little bit better, we can put this in a function. We can say function handle message, and we'll just take in a log so we don't get an error message. So let's put this inside of here. Let's save and format. Now, let me just type a bit more code and then I'll explain what we're going to do. So here, what I can do is say console.log, and then notice it's narrowing the type for me because it knows we're dealing with a warning. So I can do message. Here, I can do text, and then here, it's narrowing again for me, and it knows that I can do message. Let's zoom out a little bit and go up again and have a look at this. So we have our three interfaces. They now have a tag on them. This is known as the Discriminated Union because this is something different on all three of the interfaces. However, it has the same property name. So what we're doing is we're going down here and we are switching on that specific value. In this case, it's the type. Since it's the same property name for all of them, it allows us to do that. And then we say, okay, well, if the case is warning, we now have narrowed the type down. So we know that log must be of type warning. If it is info, we know it's of type info. If it's a success story, we know it's of type success. So just an additional way to perform type narrowing. And that's really all I had to show you in this video. Just wanted to give you that information, not because you're going to use it a ton, but because you might see it if you're working in a large TypeScript code base. And I wanted you to be aware of why this might exist and why people would actually tag their different interfaces or types. Anyways, that's all I have for you. I'm going to wrap up the video here. I hope you enjoyed it, and I look forward to seeing you in the next one. Hello, everybody, and welcome to another video in this TypeScript tutorial. In this video, I'll be talking about the utility types in TypeScript. Now, these are built-in types that you can use to make your life a little bit easier and to declare some more custom types. There's 5 that I'm going to go through in this video. We're going to start with one known as partial. So let me copy in some code here and we'll have a look at it. Let's just run the formatter. Okay, so we have some interface called to-do. This has a title and a description. We then have a function, and this has a parameter, and we're using the partial utility type. Now, what partial does is make all of the properties inside of the type that we pass to it optional. So you can see here that it says we have partial, we take in some generic value t, in this case it is to do, and now if I go in here and I start accessing properties, I can say to do dot, and notice that these are all going to be optional, so description, title, etc. So rather than defining your own new interface or making all of the values in the interface optional when you don't actually want them to be, you can use this partial type when you want to accept some of, if not all of the values from the type. So that's partial. Again, it just makes all of the different properties in the type optional. Now, the next utility type here to look at is known as read-only. Now, this is pretty straightforward, but what this will do is specify that a property is read-only and it cannot be changed, or in this case, the entire type cannot be modified. So here we have an interface to do. It has a title string. When I use the read-only utility type and then I pass to do to it as the generic, you'll see when I come down here and I say my to do dot and I try to access something like the title and set that equal to say hello, we're going to get an error here because we're using a read-only property. So it says cannot assign to title because it is a read-only property, meaning that we can't change it. So that's all read-only does. This is useful when you want to accept some object and you want to declare explicitly that you're not going to modify anything on it. So here it just makes every single one of these properties read-only. That's exactly what it means. You can only read them, you cannot change them. However, of course, you can access them. So I can say my to-do dot title, I could print it out, I can use it, I can assign it to a variable. I just can't change what the property value is inside of the object. So the next utility type to look at is something known as a record. Now, a record allows us to have some key associated with some value. So it's a way that we can create some kind of mapping type, and it's a little bit cleaner than if we were to write this on our own. So you can see that we have some interface. This interface is called page info, and it has some title. Now what we've done is we've created a pages variable, which is a record, where the key in the record is a string and the value is the page info type. So what we do is we have some string, in this case home, about, contact, and that's now associated with an instance of the page info or something that adheres to that type, which simply has a title. That's all record does. If we want to look at another example, we could say pages, and rather than be a string, we could change this to a number. We could say page numbers, and now we can do something like 0, 1, and then we can change this to 2. We've now modified this so we have a different type where we have a record that has a number key and a page info value. Obviously, these types can be anything that you want. And that's it. That is the record type for you. The next utility type we're looking at here is something known as the pick type. You can see that right here. Now, what pick will do is it will take some type t, and then it will specify all the different properties of that type that we are going to pick to be used in some new type. So here we've made a new type called toDoPreview, and we say, hey, for this type, I want all of the properties from todo that are the ones that I list here. So I'm picking them out of this specific interface. So notice that when I come down here, the toDoPreview simply has the title and completed, because those are the two that I picked. If I were to remove completed here, you can see now that this is a valid type because we've just picked the title out. Now you may be asking, why would you want to do that? Well, the reason you do that is because this is going to take whatever type those properties are from the interface. So here, rather than redefining the property and redeclaring its type, you simply pick them out of the interface, and that way they maintain whatever their original type was, and you now have two types that have some overlap in their properties, but may not include all of the exact same ones. There you go. That is the toDoPreview, or sorry, not toDoPreview, that is the pick utility type. So the last type I have to show you here is known as omit, and this is the exact opposite of pick. So what this does is it looks at some type and it omits all of the properties that you specify here, leaving all of the other ones. So here we get the exact same thing we had before. We say type toDoPreview is equal to omit todo, and then we specify any properties we don't want to include. So in this case, I don't want the ID, so that leaves me with the title and completed. Now if I do ID or title, you'll see that now it just leaves me with completed because I've omitted those two properties. So this is useful when you want to include almost all of the different properties. So rather than listing all of them out, you just list the ones that you don't want. All right, that was it for this video. I know it was pretty fast and fairly simple. I just wanted to show you these 5 different utility types that can make your life easier in TypeScript. With that said, I will wrap up the video, and I look forward to seeing you in the next one. Hello everybody, and welcome to the next video in this section. In this video, I'll be going over modules. Now, a module is really just a TypeScript file, and in a module, we can either import code or export it. The idea here is that we're not usually going to be writing our entire program in a single file. When we get into larger code bases, we're going to have many files, sometimes hundreds, if not thousands of files, and this allows us to better organize our code and to separate out different areas of our code so it's easier to locate different components. You can imagine that in a large application where we have maybe millions of lines of code, it would make no sense to have that in one file, and it would be very difficult, if not impossible, to maintain that. So I'm going to show you here how we actually structure our code with multiple files and how we import and export that code. So you can see that I have the File Explorer open on the left-hand side. We can zoom in a little bit, and I'm going to create a new file, and we'll just call this for now util.ts. Now inside of util, let's make a simple function that we may want to use inside of multiple other files or just in a different location of the code. So we're going to say function add, we'll take x, which is a number, and y, which is a number, and we'll return a number. This can return x plus y. The function itself is not important. I just want to show you how we can use this from another file. So in order to use code written in one file in another file, we need to export that code. Now there's a few ways to do this, but the most basic way is to simply write the export keyword before the function. Now when we do this, this will actually make this code accessible outside of the module and allow us to import it. Now this is what's known as a named export because we're exporting the function name add. There's other ways to perform the export. For example, I can go down here and I can type export, and then inside of a pair of braces, I can write add. This is also a named export, and this would allow me to export multiple things at the same time. So for example, if I called this sub, and then this became x minus y, we could export add and sub. These are both named exports because we've specified the name that we're exporting. As well as that, we could simply put export before both of the functions. This is also valid syntax. It's equivalent to what I just showed you before. Okay, so we have 2 functions here that we're exporting, and notice I've put them in a module called util, which stands for utility. The idea is these are some utility functions. We may use them in many different places in our code, so we put them in a separate file and we name it accordingly so we understand what's to be stored here. So now let's go to our app.ts file and let's see how we would import this. Now first notice the relative location. App.ts is in the same directory as util.ts. That means we can directly import it just by using the file name. So what I can write is import, and then I'm going to put a set of braces here, and I'm going to specify the names that I'd like to import because these were named exports. So I want to import add, and I want to import sub, and this is going to be from, and then what we do is we write the name of the module we want to import this from. So we're going to put dot, slash, and then util like so. You don't need to put the .ts. In fact, it's not going to work if you have the .ts. You just put the name of the module that you want to import. So notice I put a // though. The reason I put the / is this specifies to look in the current directory. This is what's known as a relative import, and I'm specifying, hey, based on the current location that I'm in, I want to look for the file named util. So whenever you have // that pretty much indicates wherever this file currently is, start looking from there to import, and then whatever we put after here. So we're looking for util. Okay, so now I can use this. So I can say add 1, 2. We can say const result is equal to that, and then console.log the result. And just to check our sanity here, let's compile this code. So I need to bring up the terminal here if I can get this loaded. So excuse me, but let me get the terminal open here. I'm going to type tsc. So this will compile our code. You'll now notice that we get both an app.js and a util.js file. And now what I can do is say node, and then I can run my app.js file, and you see that we get the result of 3. Okay, so the compilation worked successfully. Notice that it compiled everything that was imported as well. Okay, so let's clear this and let's go back into Zen mode where I was working before and look at some other ways of importing and exporting. So in this instance, we had the add and the subtract function, and we imported those. And you'll notice when we don't use one of the imports, it kind of goes in gray and it tells us, hey, you're importing this, but you're not using it. This is just so that we can remove it if we don't actually need it. Now, what I'm going to show you is something known as a default export. Now, a default export is something that is not named and that can be imported with any name that you want. So what I can do is write something like this, function test. Okay, we can just return test. And then I can go down here and I can type export default and then test. Now, just by the way, it is convention to put your export at the very bottom of the file. So in this case, since I'm exporting this function directly, it's fine to prefix it. But if I am going to be using a default export like I am here, then I usually just put it right at the end of the file, not necessarily beneath the function. So for example, we may actually have it like this, where we have export, and then the function test. And then we have the export at the very end of the file. That's just a convention that you'll commonly see. So I wanted to mention that. Okay, so what does that allow us to do? Well, since this is a default export, that means that we can import it just using whatever name we want. And it's important to note that you can only have a default export for one item. So I can't do test and sub, right? That's not valid. I can't do like a set of parentheses here and then put sub in. Well, I could, but it would just export something that we're not looking for. So the idea is you have one default export. So we're going to say export default test. And now in here, if I want to import that, let's just get rid of this and make it simpler. I can say import anything from util. And now what happens is anything is actually going to be the function that I specified here, which is test. So I'll show that to you. I can say console.log and then anything. I'm just doing a weird name because I want to illustrate the fact that this does indeed work. Let's untoggle the Zen mode. Let's compile and let's run our code, and notice that we get test printing out to the screen. Okay, let's go back into Zen mode here. So as you can see here, we had one default export, and now without using the braces, I can import this and I can call it anything that I want. Now let's say we want to import the default export as well as some other things. Well, in that case, I can put my braces again, and then I can add the named exports that I'd like to bring in as well. So in this case, I'm importing the default export as well as the named exports of sub and add. I'm doing that all in one line. If I really wanted to, I could separate it into 2 separate lines. So I could get rid of that, for example, and I could do it like this. That's valid, but you can actually just do it on one line in the method that I showed you here. Quick recap. We have a named export, which is when we use the export before a function. We can also export a class. We can export a variable. For example, I can say export const tim equals 1. Again, we've just exported a constant now. This is Tim. We can export anything that we want, really. It doesn't matter. And then we have the default export, which is simply writing export default, whatever you want to export. Again, we could export a variable, we could export a function, we could export a class, and you can import that using this notation. All right, so now that we've looked at that, let's look at doing some more complex imports and exports and separating our code into multiple files, functions, etc. So let's remove util for now. Okay, we can actually just delete this. And let's say that maybe we have a lot more code and we want to start making this just that much better. Well, first of all, let's get rid of all of this inside of app.ts. So what's possible, first of all, is that we might have some folder. And inside the folder, we might call this something like math. Now inside math, we may have some other folders. Maybe we have one like simple, and maybe we have one like complex. Now maybe we go in simple and we'll say that we have some util.ts file, and inside complex, we have util.ts as well. Now keep in mind, you can name these files anything that you'd like. I'm just going with utility because that makes sense in this example. So inside of util and complex, let's just have a function complex. Okay, and we're just going to return complex, and then we're going to say export default, if we can spell this correctly, complex. Now let's copy the same thing into simple, and let's just make this say, if we can spell this correctly, complex with simple. Okay, and now we have a default export for simple. Okay, so now from app.ts, let's say we want to import both of those. How would we do that? Well, I can do something like this. I can say import, and this is going to be a default export, so I can name this whatever I want. I could say complex function from, and then this is going to be dot slash, and then I'm going to make this name of my folder, which in this case is math, then slash complex, which is the name of the next folder, then slash util. Now, this is what's known again as a relative import. I said, okay, I'm going to start looking from the current directory. I'm going to look for the folder math, which I find. I'm going to look inside the math folder for the folder complex, which I find. I'm then going to look for the file utility. And now I have this complex function that I have brought in. Now we can do the exact same thing here. So let's say import simple function from dot slash math slash simple slash utility, and now I bring that in. Okay, so there you go. That's how you do a more complex import when you're doing it from a folder. Now let's look at what happens if we want to import things that have the same name. So for example, let's just go here and let's copy this and let's call this simple as well. So now we're going to have two files that both have default exports of simple, and actually rather than making them default, let's just export them named, because I want to show you what happens when we have two of the same named imports. All right, so now notice these are no longer going to work because we don't have a default export. So it says complex is declared, but its value is never read, and it says has no default export. So what I need to do is use the named export, and the named export in this case is simple. So I can do that, and I can import that from my complex function. However, what about when I try to do this again from simple? Because remember, they have the same name, right? So this is a function, this is a function as well. The problem is they have the same name. So how do I fix this? Well, TypeScript, of course, has thought of this, and what we can do is we can import them using an alias. Now, an alias is simply writing the keyword as, and then specifying the new name. So I can say something like simple as complex. Well, actually, let's do it up here because this will make more sense. Okay, so when I do this as, it says, hey, take the named export simple, but since we may have a variable called that already, we're going to instead call that complex. So now we have the function complex that is coming from the complex utility folder, and then we have the function simple coming from the simple folder. So you can use this as syntax to change it or alias the name. All right, so this is looking good, but now let's go into another case where maybe from the simple file here, we want to import the other simple function from the complex folder. I realize I should have chosen better names here, but you get the idea. From one of these two utility files, we want to import the other utility file. Well, how do we do that? So instead of simple, let's go ahead and attempt this. We're going to say import, and this is going to be simple as new function from, and now we need to do a relative import again, except this time we're going to go back a directory. So when we type // what that does is it looks in the parent directory. So whenever you have these two dots and a slash, it means look in the parent directory of wherever we currently are. So in this case, it means, hey, don't look in the simple directory, look in the directory storing simple, which is math. So now we have // and then I can write complex / utility. So now I'm looking inside of this complex file because I looked in the parent directory, I looked in the complex directory, then I looked in util. Okay, so that's how you do that. Now let's say we want to go back 2 directories. Maybe we have something inside of app here. So let's remove this and say export default constant hello world equals Tim. Now you're going to realize that that doesn't work. So we need to instead take our constant hello world and then we can write this. So sometimes the export default is not a valid prefix based on how TypeScript parses the code. So you can just make the constant and then you can export default it. So that's what we're doing here. So now let's say from this file here, we want to import from app.ts, which is actually 2 parent directories away. Well, the way we do this now is we say import, and we'll just go def for default from, and this is going to be // again. And what that does is go 2 parent directory levels up, and then we can say app, and now we have access to this here, which is equal to Tim. Okay, so that's how you go up multiple directories. Now there is a lot more complex ways to perform the imports here, and you can actually have what's known as a path import, which means you can specify a shorthand for importing specific modules or specific areas of the code that don't involve you having to use this relative import. But for now, that's all that I'm going to show you. Just keep in mind that when you get into larger projects, it's likely that you'll have some more advanced configuration that you'll need to understand before you know how you can properly import and export things from your different TypeScript modules. Now, fortunately, you're not often going to have to write this on your own. Typically, if you're working in some kind of job, it will already be set up for you. And then you just have to learn how that configuration works, which can be quite fast. But I'm just mentioning this to you because there's so many different ways to set up TypeScript and ways to set up aliased import paths and all these complex things that I don't want to confuse you with right now. As long as you understand how you export and how you import using the named export and the default export, you're good to go. The only thing that might change is the path that you're using here to actually perform that export. Again, we're using something known as a relative path, so relative to the current location. In some other projects, you use a more absolute path or use what's known as an aliased path, which can make this a little bit simpler to understand and can clean up the code a bit. Again, we don't need to get into it right now. So with that said, I'm going to wrap up the video here. I hope you found it helpful, and I look forward to seeing you in the next one. Hello everybody, and welcome to the next video in this TypeScript course. In this video, I'll be going over namespaces. Now, a namespace is similar to a TypeScript module, except it allows you to organize code into different blocks within an individual file. Now, a namespace is actually not recommended to be used unless you only have access to one file. You should prefer using the TypeScript modules, which we looked at in the previous video. Regardless, I'm going to show it to you because if you work in an older code base, you may see it, and it's worth understanding how it works, but I wouldn't be writing this unless you have a specific reason to. So let's make a namespace. You're going to just say namespace, and then you're going to give it a name. So we can do something like utils, the classic example that we've had many times now. Inside of utils, we can now export things like we would within a TypeScript module. So I can say something like export class. We can just call this my class. We don't have to actually give this an implementation. We can export a function, my func, like so. And we can export a constant maybe, export const name is equal to Tim, whatever you want, right? Also, we can export types. So I could say export type, new type, and this can be equal to something like, I don't know, name string. We could export an interface. So I could say interface like that, and then we just have to write the interface correctly. You guys get the idea. Okay, so we've got a bunch of stuff exported now here inside of the namespace. If we want to start using this now, we pretty much just use whatever we've defined with the prefix equal to the name of the namespace. So I can go here and say something like const result is equal to utils dot, and then you see we have our different exports. So my class, name, and my func. So maybe we call my function and we get some results. Okay, so we're just organizing a bunch of things of code inside of this namespace, very similar to what we would do if we put this inside of a TypeScript module. Let's say we actually want to use this type. Well, now I could say something like utils dot, and then I'm going to use the new type here, right? And then I could type whatever the result is going to be. Okay, that's pretty much it for namespaces. Now, let's say we want to import a namespace from another file. So let's go with, I don't know, file.ts. Let's see if we can just start using this namespace. We'll say const result is equal to utils, like that, dot, and then name. Notice that I don't actually have to import the namespace. Just by default, we have access to it because it's in this TypeScript project. So kind of different there. When we define the namespace, we don't need to actually import it or export it, but whatever is inside of the namespace, we do. So it's like creating a module inside of another module, and this now allows us to create multiple namespaces in the same file. Again, not recommended, but I wanted to quickly show you how that works. Okay, so that's it for namespaces. Just to kind of end off this video here, I want to give you a quick idea of how we actually typically will separate out some of our TypeScript code. So the first thing to understand is that we're probably going to have a file or multiple file called types.ts. Now this file will simply contain all of the different type definitions that we'll be using throughout our project. It's because it's nice to keep all of these types in one place and to keep them organized. So rather than just defining types all over the place in a bunch of different files, if they're going to be used in many different places, we'll typically centralize them and put them in one file. So that means that inside of here, I may say interface, client, response equals whatever, right? And I would just define all the different types that I'm going to have inside of this type file. Now, one thing to note though is that if you start getting into larger and larger projects, this file can easily get very, very large. If that's the case, then what you'll start doing is separating your types into multiple files based on where they're going to be used. Now, I know it's hard to illustrate because we are in a small project here, but let's say we have some directory structure like source, then inside of here we have something like components, then maybe we have something like an API. You get the idea. We might have like a bunch of different directories here. Now, inside of each of these directories, we may have their own types file, and this types file will specify the types directly for our components and for our API. We then may have another types file in the root directory, and this may have some shared types that are used across the API and across the components. Now it can get much more complicated, and we can actually create our own modules, which we can import and install and bring into various projects. But I'm just trying to give you a sense of why this is important, because again, when you get into larger and larger projects, you start having tons of different directories, tons of different files. And although it is a good idea to put the types in one file, often you'll spread them out across multiple types file, where all of these types files just contain the types that you need, but for the specific directory that they're inside of. All right, so that's pretty much all I had for you guys. I hope that you found this helpful, and I look forward to seeing you in the next video. Hello everybody, and welcome to the next video in this TypeScript course. In this video, I'll be going over a project that we're going to give you to allow you to practice your TypeScript skills. Now this project is going to be a blackjack card game. I'm sure many of you are familiar with this game, but if you're not, don't worry, I'll give you a quick explanation, and you can also look it up online. There are tons of resources to understand how to play this game. Now what we'll do is we'll link a Google Drive folder underneath this lesson that'll have all of the resources and assets you need to be able to complete this project. The idea is you're going to give this project a go on your own, and then you can reference the solution afterwards. So I'll start walking you through this document, but remember that you can reference this afterwards on your own, so don't feel like you need to memorize everything that I'm saying in this video. This is just meant as a quick introduction to give you some added context if this isn't enough for you. So as it says here, this document contains the instructions for a take-home project involving implementing a blackjack card game. Now this is going to be a simplified version of the game, and what that means is we're not going to have advanced rules like splitting, double down, or surrendering, which you're probably familiar with if you've ever played blackjack before. Now obviously we are not supporting gambling here. This is just a really good game for a TypeScript project, and it's one I use for a bunch of different courses and to really allow people to practice their skills, just because it's somewhat complex, but it doesn't take a super long time to build out. Now, just to clarify here, the only options that the player will have in the game will be hit or stand. If you don't yet know the game, don't worry, we'll go through a quick explanation. Now, there's a little bit of a description you can read through here, and one thing to note is that we're going to provide you with a starting code or some template that you can work off of if you're having some trouble. So I'm going to recommend that for this project, you attempt to build it completely on your own, completely from scratch. However, if that's really intimidating or you're having some trouble doing that, then what we've provided here is a folder with a template. You can download all of these different files. You can just download the folder and open up it VS Code, and it has everything set up for you and contains contains some starting code, which I'll walk you through, which will kind of give you some hints on how to tackle the project. So again, you don't need to use this. I'd recommend you don't, but if you're having some issues, then go ahead and reference the template and the starting code. Now we also have a solution. Obviously, don't look at the solution until you've attempted the project. The solution will be covered in another video, and we have all of the code there. It's also worth noting that there are many different ways to complete this project. So if your code doesn't match with the solution, that's totally fine. And in fact, it probably shouldn't. Now, a few other things here. For this project, this is going to be a Node.js based project. What that means is that we're running this in the terminal or in the command line. We're not using any HTML or CSS. Now, with that in mind, we need a way to collect user input, and there's actually an npm package that lets us do that, and it's called prompt sync. Now, what you can do to install it is simply run the command npm install prompt sync. Now, you'll need to have a package.json file created already and be in a project for that to work. And then you can install the types for this. Whenever you're working in TypeScript, there's something known as a types declaration file, which you can install, which will specify all of the types for this prompt sync module. So you're going to run both of these different commands. Once you have the package.json set up, it will install this for you, and then you can use it using the code snippet that I provided here. So you can import prompt sync, and then you can say const prompt is equal to prompt sync, and then you can use this, and what it will do is simply give you the string that whoever types in here. So it'll give you a string of whatever the person types in, and then what you're specifying in the quotation marks is the prompt or the string that you want to kind of type out first, and then they'll allow the user to start typing afterwards. I'll show you that in a second. I know there's a lot of stuff here. I'm just going through the file kind of line by line. Okay, next, for this project, you're going to need a way to shuffle the cards because we're going to have a deck of cards for this blackjack game. So I'm just providing you here with a function that can do that. You're probably not familiar with how to implement your own shuffle algorithm. So I've just written one here that you can copy in and use. It's also provided in the starting code, but I just wanted to put it here so you guys have it. Okay, so now that we've gone through all of that, you can see that we have an explanation of how the game of blackjack works. Now, this is often known as 21. It's a card game. It's very popular in casinos. And the idea is you are a player and you are playing against the dealer. The goal of the game is to have a total hand value. So the cards are in your hand and they will add up to a certain value as close to 21 as possible without going over. Hence why it's called 21. Now here's a detailed breakdown of the game. So we have a setup. The game uses a standard deck of 52 cards, or 52 playing cards, sorry. In a real casino, you typically play with more than one deck, but here we're just going to go with one deck. Each card has a value. So the number cards 2 through 10 are worth their face value. So the card 2 is worth 2, the card 3 is worth 3, etc. Face cards, so jack, queen, or king, are worth 10 points, and aces can be either worth 1 or 11, whatever is going to be most advantageous to the player. So whatever would give them the value that's as close to 21 as possible without going over. Okay, the player starts with a bankroll of $100. You could change this if you want, it's just what we're setting for now. And before each round, the player will place a bet, and if the player runs out of money, the game will end. Okay, so that's the setup. In terms of the flow of the game, you're first going to ask the player to place a bet. You're then going to deal cards. There'll be 2 cards dealt to the player, 2 cards dealt to the dealer. The dealer is going to have one of the cards hidden, so you don't know what their other card is. It's then going to be the player's turn. If the player first 2 initial cards are 21, so an ace and any 10 value card, this is called blackjack, and immediately the player is going to win 3-2 on their bet. What that means is if they bet $10, they're going to win $15. They're going to win 1.5 times whatever the bet amount was. Now, in this case, the game is going to immediately end. In real blackjack, there's some other rules here, but we're just going to say if the player gets 21, so on their first 2 cards that they have, if they have 21, they immediately win no matter what the dealer has. Now, if they do not have a blackjack, then the player has the option to hit, which is requesting an additional card. So this can allow them to get closer to blackjack or closer to 21, one try at a time. So they get 1 card at a time. Every time they get a card, they'll get another decision. Do they want to hit or do they want to stay? Now, if the player hits and exceeds 21, so if their hand value goes above that with the additional card, they bust and they automatically lose. The player also has the option to stand, which is to not take any more cards if they're satisfied with whatever their hand value is. And I'll show you some examples in a second so you get the idea. Next, we have the dealer's turn. So after the player stands, the dealer reveals their hitting card. And then for the dealer, it's quite simple. They just have to hit their hand anytime the value is less than 17. So if the total value of their cards is less than 17, they must hit. Otherwise, they must stand. And if they go over 17 when they are hitting the cards, then they bust and you would win the hand. So the reason why the casino has the advantage here is because you need to go first. So you always have a higher probability of busting than the dealer because they can just wait for you and see if you're going to bust or not, right? So how do you determine the winner here? Well, if the dealer busts or the player's total is closer to 21 than the dealer's without exceeding 21, the player wins and it doubles their bet. If both the player and the dealer have the same total, then it's a tie or a push and the original bet is returned. If the dealer has a higher total than the player without busting, or if the player busts, then the player loses their bet. Then there's a few examples here of some gameplay. You can read through them. It goes through a bunch of different cases. So you can really understand how it works. But what I'm going to show you here is actually running the finished code in VS Code. I'm then going to walk you through the template so you understand how to get started. Okay, so let me go ahead and hit enter here, and it looks as though we're getting an error. Of course, that's the case. Let me fix this up and I'll be right back. All right, so I've just run the official solution here, and I'm gonna walk you through how it works and kind of show you just the finished code. So it says player funds $100, just telling us our starting balance that we need to enter a bet. Let's say we enter something like -2, notice it says invalid bet. If we enter hello, invalid bet. If we enter something like 101, invalid bet, but 100 is completely fine because that's the starting balance. Now it prints out that our hand is a jack and a 3 and tells us the total is 13. It then says the dealer's hand is an ace and they have some hidden card that we don't yet know. So we now have our action. We can either hit or stand. So in my case, I'm going to hit, and you can see that I get a 2 now, and so my total is 15. Now I should really hit again. When I do this, I get 21. Obviously at this point, I'd like to stand, so I go ahead and stand. Now the dealer had an ace and a 7. Their total is 18 because an ace can be an 11 or a 1. So we won $200, which was 2 times our bet. So now we can enter another bet. So let's go $100. We have a 7. We should probably hit. We now have 11. We should hit again. We have a 19. Okay, so let's go ahead and stand. And you can see that the dealer now had a 6 and a 9. So they're forced to hit because their hand value is beneath 17. They get a 2, so they go up to 17. So they have to stay now. So now it says we won $200. Okay, let's enter a bet again. Let's go for 150. We have a 3 and a 9, which is a 12. They have a jack. So let's go ahead and hit. When we do this, we get 14. Let's hit again. And now we got 24 because we got a 10. So we bust and we lost. And now we have $150 left. Hopefully you're getting the idea here. I'm just playing out a few cases. We have a king 9. So that's 19 versus a 6. So let's stand. And you can see that the dealer now hits. So they have 6, 2, 5, 13. They need to hit again. They get a 10. They bust and we win. That's it. That's how the game is played. So let me exit out of this here and I'll clear that. And let's quickly run through the template now so you can understand how to get the starting code working. All right, so again, I'm gonna recommend that what you do here is try to build this completely on your own and only use the starting code if you really can't figure it out. I think it's good practice to start with nothing on your screen, no code, go through the commands again, creating the tsconfig file, creating the package.json file, installing TypeScript, and setting up some different files. Now you can code this in any way that you'd like, so long as the project actually functions as described in the PDF file and the prompt. But what I've done here is I've given you a template that will kind of give you a hint on how to start if you're struggling. So what you can do, is download the template, unzip it, open it in VS Code, and you'll see that we have a bunch of different files. So first of all, we have a types.ts file. Now inside of here, I've defined some types just to make your life a little bit easier and to show you how we implement things like interfaces and how we use an enum for the different suits for our game. Okay. I then have a utilities file, so utils.py. Inside of here, I've stubbed some functions. These are functions I recommend that you write that you can then utilize from the main file. So we have getting a decision, getting the hand value, shuffling the array, getting a bet, getting the string representation of a hand. You can change these, you don't need to use them, but this is what's involved in the official solution. So I've given you the function definition and you now need to complete those functions. We then have a deck.ts file. This is something again that you'll need to complete. Notice that it implements the idealable interface, meaning you now need to write the reset function and the deal function that adheres to the interface. We then have card.ts. Now I've written this one out for you, so you can obviously read through the code and see how it works, but this is already finished. The idea is we have a representation for every single one of our cards. So 1 to 13, 1 represents ace, and then 11, 12, and 13 are the jack, queen, and king respectively. And you see that we have a function that gets the name of a card, and it tells us what the actual kind of string representation is by using this mapping that I've created. This was a little bit complex, so I figured I'd write it for you so you can then use the card in your application. Now, the cards are going to be handled by the deck, right? Where the deck is dealing out different instances of these cards. And then we have app.ts. Let me zoom out a little bit. Inside of here, we have a function for the player turn and for the dealer turn, just to separate our code and make it a little bit easier to understand. And then I've gone ahead and I've written the entire main line of the program for you. So this handles if the dealer has blackjack, if the player has blackjack, the push case, if you lost the dealer. So you can see that it's kind of holding your hand here, right? Because I've written a fair amount of code. But the idea is that if you're really struggling, at least you have this, and it should be easier for you to actually complete this project. So I recommend read through the template, understand how it works before you start using it. And again, I highly recommend not even using this and just trying the project completely from scratch. So with that said, guys, that's going to wrap up this video. I just wanted to quickly introduce you to this blackjack project. It's a great way to learn TypeScript and to get better at JavaScript in general. Please give it a shot. It is challenging, so it will take you a bit of time. That's the point. Feel free to use Google, feel free to ask ChatGPT, use your resources, but just attempt to build this on your own. That's where you're going to get the most amount of value. Anyways, I hope you guys enjoyed this video, and I look forward to seeing you in the next one. Hello everybody, and welcome to another video in this TypeScript course. In this video, I'll be walking you through the blackjack project. Now, before you watch this video, please attempt this. You're not going to get any value out of this project if you don't at least attempt to do it on your own first. So please give it a shot. Even if you need to reference the solution a little bit, that's okay. But please try to finish it on your own before you watch this video. Okay, with that said, let's dive into it. Now, this is not going to be super in-depth. I just want to walk you through a few key components of this code and discuss how I've structured things and laid it out just to give you a bit of insight and kind of share my experience with you. This isn't going to be line by line talking about every single component of this code. Okay, so let's begin with the structure here. You'll notice that what I've done is I've created a few different TypeScript files just to separate the code out and to make it a little bit more clean. The idea is that in my app.ts file here, I have only the code that's kind of running the application, and it makes it very easy for me to read through it by using these different helper functions, types, etc. So just to give you something, an example, of what I mean here, like when I create a new deck, from this file, I don't want to be concerned with what that's actually doing. I just want to know, okay, I made a new deck. Then I come here, okay, I'm dealing some cards from the deck. The idea is I'm using these different functions so that as I read through my code, it's very clear and easy to understand. And I don't have to be bogged down by going through a ton of implementation details of things that aren't of concern in this specific file. Then what I've done is inside of card, I've put the class specifically just for the card. So I know everything related to a card is inside this file, nothing else is here. For the deck, same thing. It's just for the deck, nothing else exists here. For the types, it's just my types. And then for utils here, I have a few utility functions, so I put them all in one file. And then again, I don't need to be concerned with these implementation details when I use them from my main app file. So let's start by going to app.ts here. Let's walk through the general flow of this, and then we can go into the individual files after. So where it actually makes most sense to start here is down in the main line of the program, which is where we're going to start executing our code. Okay, so we begin here by defining two variables, dealer hand and player hand. Now notice that I say that these are going to be an array of the interface iCard. Now iCard is an interface that I've created inside of types.ts. You don't need to make an interface. You could theoretically just make it the type of the class, which is card, or really any type that you want. It could be something different. But in this case, we specified interface. And the reason we call it iCard is because the I is to indicate this is an interface type, not actually a type of a class, because we have a class called card. So instead here I have iCard, right? Now for a card, we know we're going to have a value. We're going to have a suit, which is an instance of this enum, and we're going to have some function called getName. So I intentionally use the interface here inside of app.ts because I don't actually care about the underlying implementation of the card. I just want to make sure that I have those different properties, right? So the value, the suit, and the getName. This makes my code more flexible and allows me to use different types of cards if I were to eventually want to do that. Okay, next we have player hand. So we say let player hand iCard, again, same thing, equal an empty array. So the reason we're doing this here is we're going to use arrays to store all of the cards that are in the player and dealer hand. Then we create a new deck. So in this instance, I say, okay, constant deck. This is of type deck, and we're going to instantiate the deck class. If we go look at the deck class, this also implements an interface. And if I go into the interface, you can see that the only two things we care about for the, the deck class here are that we have the ability to deal some cards, and we have the ability to reset the deck. And notice here for deal, I'm using the iCard interface because again, I don't care about the implementation of the card. I just care that it has these different methods. Okay, so let's go back. I know I'm jumping all around here, but I just want to get through the main types that I've created because this is overall TypeScript, right? Then what I do is I create a balance. Balance is 100. You can set this to whatever you want, but that's the starting balance. We then have a while loop, and the idea is we'll continue to prompt the player to play until they run out of money. So that's why the condition here is balance greater than 0. We start by printing out how much money the player has, and then we get the bet from the player. We don't need to go into that function, but the idea is this function will give us a valid bet. Then we immediately subtract the bet from the balance. Moving on, we now deal the cards. Now the first thing we do is we want to reset the deck, and when we reset the deck, this will shuffle the cards for us and give us a fresh deck with all 52 cards. We then create a player hand and a dealer hand by dealing 2 cards and getting them inside of an array. So if we look at deal here, we can see that this returns card, and this is an array. And when we put 2 here, this is the number of cards that we're dealing. So we're going to have 2 cards for the player hand, 2 cards for the dealer hand. That's how we start. Next, we get the value of the player hand and the value of the dealer hand. And the reason we want that is so that we can print out some information about the hands and we can check if either of the players have 21. The first thing we need to do is kind of perform that check. Okay, does the player have 21? If they do, they need to win right away. And if the dealer has 21, then they need to win right away. So that's why we get the hand values immediately. And again, right now, just imagine this gives us the correct value. We can look at the implementation details afterwards. We then print out that our hand is, and then we get a string representation of the hand. That's what this function will do. And then we specify what the total of the hand is by printing out what the player value is. So the value of the player's hand. We then do the same thing for the dealer's hand, but this time when we call getStringHand, we're going to pass a variable called hideSecondCard, which is equal to true, which indicates that we don't want to display what that second card is. And what that also means is that we're not going to show what the total of the hand is because we don't want the player to know that. We just want to show them one card. Okay. Next, we check if the player's hand value is 21. If it is, we need to return their bet times 1.5. So the bet plus 1.5 times their bet. So in this case, 2.5 times their bet. So we say console.log blackjack, you won, and then the amount that they won, and we add that to the balance. We then continue because at this point, since they've won, we can go back up to the while loop and continue playing. Next, we have the else if. So if the player did not win, or didn't have 21, we check if the dealer had 21. If they did, then what we're going to do is reveal what the dealer's hand was. So we're going to print out this time without hiding the second card, and we're going to show the total of 21. We know that's the case because that's what it is here. We're then going to print out the dealer has blackjack, you lost, and then again, we're going to go back up to the top. So once we get past this kind of block of code here, we know that neither player or the player or dealer has 21, and now we need to move into the player's turn. Now the player's turn is going to involve hitting until they either bust or they decide to stand. Notice again, as I'm reading through this, I don't actually really care about what the implementation of player turn is. I just know that this is going to execute the player's turn, and then afterwards they're going to have some kind of value, which we're going to store here for their hand. So player turn takes in the hand, takes in the deck, and then it returns to us what their hand value is after their turn has finished. So we can check here if they went over 21. If they did, then they bust, and again, they lose, and we can continue. Now, let's say they did not go over 21. Now we have their final hand value, and now it's time for the dealer's turn. So if the player went and didn't bust, it's time for the dealer to go. So we do the dealer's turn, same thing. We don't really care about what's happening here. We just know that we're going to get whatever the final value is of the dealer's hand. We then check if the final dealer value is over 21, so if they busted, or if our player value is greater than the dealer value, If that's the case, that means that we won, so we multiply the bet by 2 and return that to the balance, and then say that we won. Okay, so we're checking the player win condition here, which is the dealer busting, or us having a higher hand value than the dealer. Okay, now we check if the dealer value and the player value are the same. If that's the case, then we pushed and it's a tie and we need to return the original bet. Otherwise, we lost and we don't need to modify the balance because we already subtracted what the bet was. If we get outside of the while loop, we print out you ran out of money, and that's it for the main line of the program. So now let's go into the dealer turn and into the player turn, and then we'll look at some more implementation details of the classes and the utility functions. So inside of player turn here, we take in a player hand, which is anything with the type iCard that is an array. So again, we don't actually care about what the card is. We don't care about the implementation. We just need to know that all of our cards are going to have a value on them so that we're able to check that. Okay, next we take in a deck. The reason we need the deck is we're going to use the deck to add an additional card to the player's hand if they decide to hit. We then return a number. Okay, so we say let the hand value equal get hand value. So again, just imagine this returns to us what the value of the player's hand is. We're going to say while true, and we're going to get the decision from the player. Again, we don't care about the implementation here, but if we go over get decision, we can see that this is going to return either hit or stand. So I check if they are not hitting. If they are not hitting, that means they're standing, and then we can return the hand value. We also, if we want it to be more clear, could change this to just say if they are standing. Doesn't really matter. We can also do not hit. So if they're not hitting, we'll return the hand value. Otherwise, they are hitting. So if they are hitting, what we're going to do is say player hand dot push, and then we're going to deal one card from the deck. But since this isn't an array, we're going to grab the first index from that array, which is the one card that was dealt. The reason I've set up deal here with number of cards is because we could be dealing one card or two card, and I didn't want to write two separate methods. So in this case, we have deal, right? One card, and then we just grab whatever that card is and we put that inside of the player's hand. Now that the player's hand has changed, we need to recalculate what their hand value is. So we do that. And then we print out what their new hand is. So we get the string representation of their hand, and then we print what the new total is, and now they're able to see what they currently have. We now check if they are over 21. If they are over 21, they busted, and we'll immediately return the hand value, and their turn is over. Otherwise, we keep going until they either bust or they decide to stand. That's it. That's how the player's turn works. Next, the dealer's turn. This is pretty straightforward. We start by getting the value of the dealer's hand. Same thing, while this is true, we're going to print out what the dealer's hand is. At this point, the player's already gone, so we can reveal all of the cards in the dealer's hand. So we go ahead and do that. We print the total. We then check if their hand value is greater than or equal to 17. If it is, we need to stop their turn, so we immediately return the hand value. Otherwise, we deal them one card in the same fashion that we dealt the player. That's it. Eventually, when we keep hitting, they are going to have a hand value that's greater than or equal to 17. It may be even over 21, in which case they busted. Doesn't matter. We're going to return when that's the case. Perfect. So that's it for this one file. I feel like this is somewhat straightforward, and a lot of this was actually written inside of the template, so most of it you didn't need to write yourself. Anyways, let's now go over and start looking at card and deck. Now, I believe card was a class that I already had implemented for you. And the reason I did that is just because we had this big mapping, and I'm sure some of you were going to be a little bit confused by that. So what I've done here is created a static read-only card values variable. Now what this means is that we cannot change this value, so it is a constant. And when I make this static, I associate it with the card class. The reason I'm doing that is because I only want this to be associated with the class, not every instance of the class, because it's not going to change for the different instances. So this is what's known as a class variable or a static variable. Anyways, doesn't really matter, but in this case, it's associated with the class. Okay, now here we make this type record. Now remember that record is a mapping type, so we have some key associated with some value. In this case, the key is some number, and the value is some string. The point here is that every single one of our cards will be represented with an integer, and then when we actually want to get the string representation of them, we will simply pass the integer to this mapping type, and then it will return to us what the associated value is, so we can print that out and it looks like it's real cards. We then have a value property for every instance of the card, as well as a suit property. This is of type enum, and the enum type contains the different suit symbols that we'll be using. We take in a constructor, or we have a constructor, sorry. The constructor takes in a value, which is one of these numbers, and a suit, which is one of the enums from the suit enum. We assign those as the properties, and then we have a simple get name function. This simply looks up what the actual name or kind of string representation of the card is based on the value. So you can see this is card.card values, this dot value. Notice we're using the card class name to access this variable because it's static as opposed to using this. Okay, that's card, and then you can see, that we export this as the default export from card. Now we can go to deck. Inside of deck, you can see that we're importing a few things like shuffling the array, which comes from the utility file, which I provided to you. We create a private instance variable here called deck. Now, the reason we make this private is because we don't want anyone to modify this. We want them to use the interface, which in this case is idealable. So reset and deal, that's the two functions we want them to be able to use. We don't want them to use anything else. Now, when they initialize this, we're going to reset the deck. When we reset the deck, we make the deck and then we shuffle it. Let's look at the make deck function. Now, this is private, meaning it can only be called internally from this class. Again, we don't want anyone else calling this. We just want the class to handle it. Inside of here, we create a new array, which will contain our 52 cards. What we'll then do is create an array of the different suits. The reason we do this is so that we can access all 4 of the suits because we need to set up a loop structure like this. The first loop is looping through all of the different suits. So for every single suit, we need to generate every single value. So we do that, we go through all the suits. We then go through all the different values, which are 1 to 13, because that's the number of unique cards. Then we create a new card. The way we make a new card is we associate the value with it, and then we pass in the suit that we are currently on, again, going through all 4 of the different suits. We then push that into the card list, or array, and then finally we return the cards. Now at this point we've created the deck, however it is in sorted order and we don't want that, we want it to be randomized. So what we do now is we say this.deck is equal to shuffle array and we shuffle the cards that we just got, and then we use that shuffle function to, well, shuffle it, and it gives us kind of a randomized version of the cards. Okay, now we have deal. Inside of deal, we take in a number of cards that we want to deal. We're going to have an array that we return of cards. We could really make this iCard. In fact, that would probably be better. And that would just require me to change this here and import it. Doesn't really matter, but iCard is going to kind of fit with that standard of what we were doing before, and it's not going to mess anything up in our program. Okay, so now that we have this empty array, we now need to populate it. So we say let I equal 0, I less than num. So just doing this loop for the number of cards we need to deal. We then pop whatever the last card is off of the deck, and then we push that into the dealt cards. Now notice that I've added a bang here. The reason that I've added a bang is because if we look at pop, it's returning a card or undefined, whereas dealt cards here is just storing the iCard type. So if I have just card here, it could technically be undefined, and that's going to give us an error here in the type assertion. So what I do is add a bang. When I add bang, that indicates that this will never be undefined. That's all. It's not best practice to use this, but in this case it's fine because we know we're always going to have at least one card inside of the deck. Then we return the dealt cards, and that is the deck implementation. Okay, so we've gone through card, we've gone through deck, we've gone through app. We can look at the types. Straightforward, we have the iCard interface, we have the idealable interface, and then we have suit. Now this just allows us to store diamonds, hearts, spades, and clubs. So these kind of nice variable names associated with the symbol that will print out for them. And we'll use these when we actually start looking at some of the utility functions here. Okay, a few utility functions. First of all, we use the prompt sync module, which I talked to you about in the first video. So here we have a function get decision. It returns hit or stand. So while true, it asks for a decision. It says your action hit or stand. We then convert it to lowercase to make sure that if they type in something in uppercase, it will still be accepted. We then check if the decision is either stand or hit. If it is one of those two, which are the valid options, we return the decision. Otherwise, we keep looping until they give us one of these two decisions. Now you'll notice the decision is always going to be either hit or stand because of the check that we do right here. So now we move on to the get hand value function. Inside of this function, we determine the value of the hand, and I'm just going to quickly walk through how this works. So first of all, what we need to do is loop through all of the different cards, and we're going to keep track of the number of aces that we have, which are the special cards, which can be 1 or 11, and what the value of all the other cards are. So we loop through all of the cards, and we check if the card is an ace. If it is an ace, then we're going to add 1 to the number of aces that we have, and then we're going to continue. We're not going to touch the value yet. The reason for that is that we're going to handle these aces, especially at the end of the program. We're not going to deal with them yet. Otherwise, we're simply going to take the value and we're going to add the math.minimum of the card value and 10. Now, the way that this works is that if we have a value like 11, 12, 13, so the Jack, Queen, King, we're just going to treat that as a 10 rather than an 11, 12, or 13. So that's why we have the math.minimum. If it's less than that, then it will just be what the original face value was, or what the original card value was, sorry. Now down here, we have 3 different cases for the aces. So if we have 0 aces, we simply return the value. If the value is greater than or equal to 11, that means we cannot treat any of the aces as if they were an 11, because that would put us over 21. So we simply return what the value is plus the number of aces. Now, if the value is not greater than or equal to 11, then we can treat one of the aces as an 11. So we say value plus 11 plus the number of aces minus 1, because we've used one of the aces as an 11, and this will never be negative because we've already checked if there was 0 aces. That's it. You can look into this more if you want, but that's how you handle the hand value with aces. Now we have some functions. This one's pretty straightforward. It simply gets the bet for the user. I'm not going to walk through it. All it's doing is making sure you give a valid bet between 0 and the balance that we pass to the function, and then gives you some output messages, and it returns a number. Lastly, we have get string hand. I can quickly talk about this one. So in this case, we take in the hand and we take in a parameter for hiding the second card or not. We just are going to create a string here by looping through the different cards, which will show you your different cards. So we say for const idx card of hand.entries. Now what this will do is loop through all of the values in our hand, so all of the different cards, and give us the index of them. The reason we need the index is to handle when we add a comma and if we're hiding the second card. So if the index is not equal to 0, then what that means is that we can add a comma. The reason for that is that we're going to add a comma before the next card that we put into this string. So when we're on 0, we don't add a comma because we haven't yet put a card in, right? Then what we do is we say if the index is 1 and we're hiding the second card, then we're just going to add this string, which is hidden, rather than actually showing what the card is. And then we're going to break out of the loop because at this point there should be no more cards to show. Otherwise, all we do is we say string plus equal to, and then we get the name of the card, and then we simply print out what the suit is, and that's it. And then we return this string. So that'll give us a string that looks like 7, and then I can't do the symbol because I don't know the keyboard shortcut, but it would be like a heart would appear here, and then there'd be a comma, and then for example, we might show hidden, right? Or whatever the next value would be. Okay, so with that said, guys, that pretty much wraps up all of the code here. Not much more for me to go through. Feel free to look through the code, read it on your own. If you have any questions, of course, let us know. I hope you found this video helpful, and I look forward to seeing you in another one.